Yeah, hi everyone, welcome to PrepFusion. So we are continuing our lecture on linear algebra. So how we started our chapter? First we studied about basics of matrix and determinants. Then we studied about rank. Then we studied about system of linear equations. And now we are going to study about vector. Okay. So here we will study about, first we will study about dimension of vector. Then we will study about the span of vector set. Then we will study about vector space, vector subspace, right? Basis of the vector subspace. All those things we will study. Then we will study about null space as well. So now what really happens is that a lot of people find a vector space complex. Okay, this is the topic where a lot of students would struggle. That's why we don't understand vector space. But the actuality is that everything is related with rank. Did you watch the previous video, system of linear equation? That was completely related with rank. If you know the rank, then you will be able to understand, otherwise you will not be able to understand. So there is a certain order of following the videos. Okay, you should start right from the beginning and then you should come to this video, because a lot of people will only see the thumbnail and they will come to this video thinking that they will be able to understand. But I will relate a lot of things with the previous videos. Okay, so everything is interrelated. If you want to understand this particular topic, then start right from the beginning. If you are someone following right from the beginning, then it is pretty good. If you just came here for one particular topic, then I guess you might not get too much happy. If you feel like that, sir, I am completely comfortable about the concept of rank, then you can proceed in the video. Otherwise, you might feel some problems. Okay, not only finding the rank, you should know the actual meaning of rank, that what rank actually represents. Understandable? So let's get started with this video. So have we already seen the representation of a vector? Yes, we can represent a vector in column form or in row form, right? So this is known as column vector, this is known as row vector. So what is the order here? 3 cross 1. And what is the order here? 1 cross 3. So our vector was 3 I cap plus 2 j cap plus 5 k cap. I represented that vector in matrix form. This is column vector and this is row vector. What this is known as? This is known as column vector. And the other one is known as the row vector. Okay. Next, what we need to study about? We need to study about the length of the vector. So what do you understand by the length of the vector? So this is the notation, no? This is the notation we use. And sometimes we can directly use capital A. The notation, which is capital A or mode of a vector, that is given by this coefficient square, a square plus b square plus c square, right? This is known as the length of a vector. Now in matrix form, how I have represented? In column vector I have represented. So what will be the notation? What will be the length? This will be the length. But what will be the notation? Notation will be this. Okay, double dash a double dash. So I will call it length of vector A. Okay, length of vector A. So double dash inside A is written. So length of vector A. What is the length of vector A? A square plus b square plus c square. So this notation might feel like, sir, this is something new for you, but you already know the concept. What does it mean? It simply means that you are talking about the length of the vector, under root a square plus b square plus c square. That's it, nothing else. Now let me know one thing. What would A transpose into A would represent? Basically what this is 3 cross 1, right? A transpose, what will be the order of A transpose? 1 cross 3. And what will be the order of A? That is already 3 cross 1. So if you multiply A transpose with A, what you are going to get? What is A transpose? So A transpose will become ABC. And if I multiply this ABC with A, what I am getting? So this has become row vector, this has become column vector. A multiplied with A will give me A square, B multiplied with B will give me B square, and C multiplied with C will give me C square, sir. So what you see here is that A transpose into A is giving you A square plus B square plus C square, which is nothing but length of A square. Will you be able to remember this thing or not? That A transpose into A will give you length of A square. Okay, this is something which we need to keep in mind. Let's see one more important point. So let x be a column vector of dimension n cross 1. So this is your column vector of dimension n cross 1. N value you can take anything. Let's just say it is 4 cross 1. So x1, x2, x3, x4. Now what will be the length of x? You know that, sir, length of x will be nothing but under root x1 square plus x2 square dot xn square. Or sir, what I can say? sir, I can write it down as under root. What this x1 square, x2 square, x3 square, dot xn square could be represented as? That could be represented as x transpose into x. Okay, this could be represented as x transpose into x, because what x transpose into x is representing? A transpose into A is representing magnitude of A square, right? Or you can simply say A transpose into A is representing A square plus B square plus C square. So similarly, x transpose into x is representing x1 square plus x2 square plus x3 square and dot xn square. Now my question is that what would trace of x into x transpose would represent? This is something you will be able to remember, right? Already there was a square. If you remove the square, here under root would come. Not a very tough thing to remember, very easy. But now what this x into x transpose would represent? Trace of x into x transpose. So what is x? X is this one. And what is x transpose? That you can write down on your own. So let's write down x first. So sir, this is my vector x. This is your vector x, and this will be your vector x transpose. Write it down and then multiply x1, x2, dot xn, x1, x2, dot xn. So what will be the final order you will be getting? The order I will be getting is n cross n. Why is that so? Because sir, here the order is n cross 1, here the order is 1 cross n. So final order will be n cross n. Now x1 multiplied with x1, x1 square. Then x1 multiplied with x2. Basically, this row is being multiplied with all the columns. So there is only one there is this column and there is only one element. So x1 multiplied with x1, x1 square. Then x1 multiplied with x2. Row being multiplied with column. This row will be multiplied with all the columns. So this column it is being multiplied x1 square. Then this column it will be multiplied. You will get x1 into x2, and then dot. Then x1 will be multiplied with xn. So you will get x1 dot xn. Right? Then x2 will be multiplied with x1. Then x2 will be multiplied with x2. You will get x2 square, and then dot x2 xn. Similarly, then xn will be multiplied with x1. Then xn will be multiplied with x2. Then dot xn square. So what trace is representing? What do you mean by trace? This main diagonal. So what this trace is representing? Trace of x into x transpose is simply x1 square plus x2 square plus x3 square, which I am not writing, dot xn square. What this is equivalent to? This is equivalent to nothing but magnitude of x whole square. What is magnitude of x? Magnitude of x is nothing but under root x1 square plus x2 square dot xn square. That would be equivalent to magnitude of x whole square. Or I can write it down as x transpose into x, because magnitude of x whole square is nothing but x transpose into x. So trace of x into x transpose is representing x transpose into x. Understandable? So you don't need to mug it up. These are some important results. Some questions might be framed from here. We will frame the question as well and we will solve it as well. But just you just need to read it, and you should have the temperament of solving in the examination hall. That's it. Okay, if such kind of questions are coming that they give you a vector and then they will ask you trace of x into x transpose would be equivalent to what? So you will directly calculate the length and then do the square. Calculate the length, do the square. That's it. Okay, so you should have the temperament of solving in the examination hall. Okay, this is the vector and this is the transpose would be there. I will solve it in this manner. I will get to know that yes, it is representing the square of the length. That's it. That would be the answer. Understandable? So nothing you need to remember. In this slide and in this slide, nothing you need to remember. Let's go to the next one. What do you mean by unit vector? So this is our vector A and this is the length of the vector. So what do you mean by unit vector? Unit vector is simply the vector divided by its length. Right? That means ai cap plus bj cap plus ck cap will be divided by under root a square plus b square plus c square. Let's call this as d. I am calling the length of vector A as d. So what I will be getting? A by d I cap, b by d j cap, c by d k cap. Understandable? Similarly here, what do you mean by normalized vector? in complete mathematics, wherever you see word normalized, which word? Normalized. Normalized means divide by the magnitude, that's it. Normalized means divide by the magnitude. Even in electronics, in MFT, you will say normalized impedance. In MFT, you will say normalized impedance, normalized load impedance. So whenever we see normalized impedance, what do? We divide by Z naught. So normalized means it will be divided by something. You are normalizing this impedance with respect to Z naught. So now you are normalizing this vector with respect to its magnitude. So what will be your normalized vector? That will be your vector A divided by its magnitude. So magnitude we are representing by D. So this vector A divided by D. What is this vector? This vector is a matrix only, no? So if you divide the matrix by some element, if you divide the matrix by some number, that means all the elements will be divided, right? If I am dividing this matrix A by D, what does that mean? That all the elements of matrix A will be divided by D. So this will become A by D, this will become B by D, and this will become C by D. There you go. Okay, so what is the meaning of normalization? Normalized means you are dividing it with something, and what you are dividing with? You are dividing with the magnitude of the vector. Understandable? Very straightforward. These are simply the words. You might see these words in your examination. Only you will think, sir, what do you mean by normalized? So you just need to remember, okay, sir has taught something like that. So I'll be able to tell, okay, normalized means divided with something. Divided with what? Divided with the magnitude. Here, sir, x into x transpose into x trace, they are asking, have we studied something like that? Yes, we have studied. Then I will be confident. I will be able to solve it. So that's why these topics I am teaching. In the examination, if questions are coming, you will be able to solve. You don't need to remember anything. Okay. What do you mean by orthogonal vectors? Orthogonal vector means they will be perpendicular to each other, basically. They will be framing 90-degree angle. Understandable? So basically, I will write down A perpendicular P. So their dot product should give me 0 result. And what will be the result of their dot product? I multiply with I, A into P plus B into Q plus C into R. Right? Here what dot product would represent? I am not going to tell now. I will directly write down the dot product will be simply A transpose into P. Sir, why is that so? I don't know why is that so. That should be equivalent to 0. How did I write down A transpose into P? This I have explained in the basics, if you remember. A transpose into P. I told you what this is. This is your 3 cross 1, and this is also your 3 cross 1. Now what you need? 1 cross 3 multiply with 3 cross 1. Then only you will get a single element, no? I explained why it is a single element. So this is a single element. So 1 into 3, 3 into 1. So this and this will get cancelled out. 1 cross 1 you will get. So A multiply with P plus B multiply with Q plus C multiply with R. And then I told you that when we study about vectors, I will directly write down A multiply with the element wise element multiplication I will do. A into P plus B into Q plus C into R, that will be equals to 0. That's it. So this is the meaning of orthogonal vectors. Now I say that A and P are set of orthonormal vectors. Okay, orthogonal, orthonormal. So whenever you see the word orthonormal, that means it will be same as orthogonal plus the length of vectors. Length of vectors will be 1. What does that mean? That means, sir, A dot P should be equals to 0, which is AP plus BQ plus CR. That should be equals to 0. Along with that, under root A square plus B square plus C square. Under root A square plus B square plus C square should be equals to 1, and that should be equals to under root P square plus Q square plus R square. That means length should also be equals to 1. So two conditions we need to satisfy. Okay, dot product 0, which was there in orthogonal as well. In orthonormal, dot product 0, along with that length should be unity. Okay, length of the vector should be unity. So what is the length here? Under root A square plus B square plus C square, that should be equals to 1. P square plus Q square plus R square, that should also be equals to 1. Because this 1 goes here, 1 square will be 1 only. So this is the condition it should satisfy. That is the meaning of orthogonal vectors and orthonormal vectors. Understandable? Now this was the discussion about two vectors only. If I am giving you multiple vectors and I am saying that A, B, C, D are set of mutually orthogonal vectors, what does that mean? That means that A is perpendicular to B, B is perpendicular to C, and C is perpendicular to D. This is the meaning of a set of mutually orthogonal vectors. What does that mean? That means A dot B, B dot C, C dot D, D dot A, AB, BC, CD, AD, then BD, and AC, right? 4C2. What is the value of 4C2? 6. 6. So there should be equals to 0. That means all are orthogonal to each other. That means A dot B should be equals to 0, B dot C should be equals to 0, C dot D should be equals to 0. A dot C, A dot C, B dot D should also be equals to 0. Understandable? All are orthogonal to each other. And what if I say they are mutually orthonormal? That means this complete condition will be satisfied. Along with that, their length would also be 1. So this condition will surely be satisfied. Along with that, their length should be equals to 1. Is that clear? Okay. Let's solve this question. U1, U2, U3, 3 vectors are given. 3 vectors are given. These are the vectors, okay? These 3 vectors are given. You need to find out which of them are true. What do you mean by linearly independent? Have we seen this kind of concept before? If I need to prove whether these 3 vectors are linearly independent or not, so what I will do? I will frame a matrix. I will frame a matrix which is having these 3 vectors as its row or column. I can represent the vector as a row or column. So I am representing this as a row. So 1 by under root 2, 1 by under root 2, 0, 1 by under root 2, minus 1 by under root 2, 0, and then 0, 0, 1. Okay. Now I need to find its rank. If rank is coming out to be 3, you can find its rank. You will simply subtract from R2, you will subtract R1. So what you will get? 1 by under root 2, 1 by under root 2, 0. Then here you will get 0, here you will get minus under root 2, here you will get 0 only, and then 0, 0, 1. It will be in the row echelon form, and you will see that rank of A is coming out to be 3. What does that mean? That means it is having 3 independent rows. 3 independent rows. And what is the meaning of 3 independent rows? That means this line, and this line are independent of each other. So vector u1, this was your vector u1, this was your vector u2, and this was your vector u3. All are independent of each other. Now someone would say that, sir, what if I would have written in this manner? Sir, you wrote down as row. What if I would have written in this manner? 1 by under root 2, 1 by under root 2, and 0, 1 by under root 2, minus 1 by under root 2, and 0, 0, 0, 1. It will also give you the same result. Here also the rank would come out to be 3 only. Here also you will get the same result. Whether you write down in row form or you write down in column form, in both of the cases you will get the same result. Here also you can say that there are 3 independent columns. The rank would represent the number of independent columns and the number of independent rows. So you can say that we are having 3 independent columns and 3 independent rows, right? So you would be able to say that all 3 are linearly independent of each other. Now are they orthogonal to each other? So what we need to do? We need to do u1 dot u2. If we do u1 dot u2, corresponding elements we need to multiply. 1 by under root 2 multiply with 1 by under root 2, what you will get? 1 by 2. 1 by under root 2 minus 1 by under root 2, what you will get? Minus 1 by 2. 0 multiply with 0, what you will get? 0. u1 is orthogonal to u2. u2 dot u3. 1 by under root 2 multiply with 0, 0. Minus 1 by 2, minus 1 by under root 2 multiply with 0, 0. 0 multiply with 1, 0, 0. u1 dot u3. 1 by under root 2 multiply with 0, 0. 1 by under root 2 multiply with 0, 0. 0 multiply with 1, 0. So all 3 conditions satisfied, they are orthogonal as well. What about orthonormal? Find out their length. what you need to find out? Find out the length of u1. So how will I write down length of u1? What is the length? Under root a square plus b square plus c square. What is a square? What is b square? And what is c square? What is the answer? 1. Length of u2, a square plus b square plus c square, 1. And what is length of u3? 0 square plus 0 square plus 1 square, 1. So length is also 1. They are orthogonal as well. That means they are orthonormal as well. And if a matrix A is formed using u1, u2, u3 as its row, then A is invertible. Yes, because it is a full rank matrix. And if it is a full rank matrix, that means yes, it is invertible. Right? What do you mean by this? That means its determinant will not be equal to 0. If it was not a full rank matrix, then its determinant would have been 0. Right? But it is a full rank matrix, that means its determinant is not equal to 0. That means yes, it is invertible. Understandable? Everything is crystal clear, right? What do you understand by orthogonal vectors? That means if this is your u1, let's just say if this is your u1, then this will be your u2. Okay, let's just say this is your u1, then this will be your u2. Can you anyhow write down this vector in terms of this vector? What I mean to say is that they are perpendicular to each other, no? They are perpendicular to each other. Like, can you find out any dependence between them? I am saying that this is u1, this is your u1, and this is your u2. Is there any dependence between them? Can you write down u2 in terms of u1? Can you write down this particular thing? Or can you write down u1 in terms of u2? If they are perpendicular to each other, let's just say u1 is I cap. What I mean to say is that u1 is I cap. And let's take some other vector. Let's take vector A as I cap and vector B as j cap. So I hope you know what is I cap. I cap means x direction. So I cap is the unit vector in x direction and j cap is the unit vector in y direction. So this will be your I cap and this will be your j cap. Can you any day write down j cap in terms of I cap? No, sir. They are completely different. No. I cap, j cap. This is representing different direction. This is representing different direction. I can never write down this j cap in terms of I cap. Not at all possible. And are they orthogonal to each other? Yes, sir. Surely. A dot p, what that come out to be? I cap dot j cap, that will be equal to 0 only. So yes, surely they are orthogonal to each other. What does that mean? Orthogonal vectors are always independent of each other. Or you can say a orthogonal set of vectors always frame independent set of vectors. Let's just say here it was given that u1, u2, u3. Here I don't even need to check option A. What I would see that u1, u2, u3, are they independent? Are they orthogonal to each other? Yes, sir, they are orthogonal to each other. That means for sure option A will also be correct. Is that clear to you or not? So I will see a particular question. If I see there that they are talking about orthogonal, if they are talking about orthogonality, then first I will check the orthogonality. Then by default I will get to know that yes, for sure they will be independent of each other. So if there are some set of vectors which are orthogonal to each other, then 101% they will be surely independent of each other as well. So will you be able to remember this line? That orthogonal vectors are always independent of each other. They always frame an independent set of vectors. Is that clear? All good? All fine? Let's go to the next question. Quickly solve this question. We have already seen it somewhere. What is given? This thing is given. What you need to find? What this thing will represent? X transpose into X. Is that correct? No. Under root. Right? Under root will also come. So what will trace of X transpose, X into X transpose would represent? Trace would represent this thing, right? I hope you remember it. Here we saw it, no? Trace of X into X transpose would represent the length square. So it would represent length square. So what is your length that is coming out to be? Length is coming out to be 5. So what will be 5 square? 25. That's the answer. So what will be the trace? Trace will be nothing but 25. Okay. So take the length and then simply find out the trace. Even if it doesn't click to you, then what you will do in the examination? You can write down any random x, and then you can write down x transpose as well. Do the multiplication, you will realize that x1 square plus x2 square plus x3 square plus x4 square plus x4 x5 square is coming. And what that is representing? That is simply representing the square of the length. So here the length is 5, so square of the length will be 25. That's the answer. Understandable? Very straightforward thing, right? Let's go to the next concept. So this is a very simple thing. What we are talking about? We are talking about the dimension. What do you mean by dimension? So forget about this slide. I am asking you a very simple thing, that wherever you are sitting, you need to work only in one dimension. Okay, that means if you are going this side, then only go this side only. Keep on working on this side. If you are going this side, then keep on working on this side. Only in one dimension you need to work. Let's just say you are here, you need to keep on working on this side. So what you will create? You will create a line, no? If I tell you that you can work only in one direction, so what you will end up creating? You will always work on a line, on a straight line. So if I say I am having, my vector is having one dimension, or my vector space is having one dimension, that means it will create a line. Is that understandable to you? If there is one dimension, that means it will be a line. And if I say that you can work in two dimension, that first you can go here, and then you can go somewhat like this. Then again you can work like this. Then again someday you can work like this, or you can work like this. So eventually what you are creating? You are creating a plane. If I say you can work in two dimension, that means you can work in the complete room now. You are at that origin, and I say go straight, and then go right, then left, in that manner. So you will be able to cover the whole plane. So if there are two dimensions, then what you will be able to cover? The complete plane. And if there are three dimensions, then what you will be cover? What you will be able to cover? Full space, right? That means I am saying that you go this side, then this side, and then come out of the screen. You work on this upper side, then right side, and then come out of the screen. Then you will be coming out of the screen. That means you are coming into the space. Firstly you are on the line, then you are on the plane, and then you are coming into the space. So if there are three dimensions, then what it will represent? It will represent the space. Let us say if there are four dimensions, which we are not able to visualize, but if there are four dimensions, then what you will say? That will be 4D space. If there are four dimensions, then that will be known as 4D space. The name will be given 4D space. Okay. If there are n dimensions, the name would be given as ND space. Okay. Understandable? Now what do you mean by dimension of a vector? Listen to the word very carefully. Dimension of a vector. So how many dimension it is having? Two dimension it is having. So two dimensional vector. How many dimension it is having? Three dimension it is having. How many dimension it is having? Four dimension it is having. And how many dimension it is having? One dimension it is having. This is the dimension. Okay. This word is very important. Dimension. Eventually you will be getting confused with the word dimension and span. So here I am writing that dimension doesn't mean span. Dimension is not equals to span, because you guys will be getting confused here. Dimension of the vector we are talking about. What we are talking about? We are talking about the dimension of vector. That means here 2i cap 3j cap, 2i cap plus j cap plus 3k cap, 2i cap plus, sorry, 1i cap plus 2j cap minus 3k cap plus l cap. Any l cap would be there, no? Some one more dimension we are taking, and here only I cap. Understandable? So what we are talking about? We are talking about that there are four coefficients. So that's why this is known as dimension. And now we are going to talk about the span. What we are going to talk about? We are going to talk about the span of a vector. What do you mean by span? This is the span. That this vector will create a line, or they will create a space, or they will create a plane, or they will create a space. This is what we need to find out. Okay. So you are given one vector 3i cap. What you are given? You are given only one vector, which is 3i cap. So what this 3i cap will create? This is what I am asking. So can you represent vector 3i cap? Yes, sir. How you can represent vector 3i cap? This is your vector 3i cap. Right? Now what I am saying, using the linear combination of this vector, you multiply this vector with any constant number. You multiply this vector with any constant number to create a new vector p. Then that vector, then where that vector would be there? What I mean to say is that what will be the location of that vector? Let's just say I am multiplying this vector A with 1 by 2. What I am doing? I am multiplying vector A with 1 by 2. So what I will be getting? 3 by 2 I cap. That will be equivalent to 1.5 I cap. So where will be 1.5 I cap? So this will be your 1.5 I cap. Right? Someone would say that, sir, let's multiply it with minus 3 by 2 A vector. So multiply your A vector with minus 3 by 2. So what you will get? Minus 9 by 2 I cap. So where will be minus 9 by 2 I cap? So your minus 9 by 2 I cap will be somewhere here. So what you will say? Sir, no matter whatever you multiply with, no matter whatever the constant number you multiply with, you will always end up getting a single line. You will always end up getting this single line. Your all the vectors will be lying on this particular single line. So what is the space here? The space, what is the span here? What is the span? Span is one dimensional. One dimensional. One dimensional. What is the span? Span is one dimensional, or you can call it line. Right? So this was a one dimensional vector. This was a one dimensional vector. One dimensional vector. One dimensional vector which is creating one dimensional span. Understandable? Span and dimension both are different thing. This is a one dimensional vector which is creating a one dimensional span. What about 3 I cap plus 2 j cap? You are given a vector 3 I cap plus 2 j cap. Can you make this vector? Yes, sir. Surely I can make this vector 3 I cap plus 2 j cap. 3 I cap plus 2 j cap. So 3 here, 2 here. So this is how 3 I cap plus 2 j cap would look like. Somewhat like this, right? This is your 3 I cap plus 2 j cap. This is your vector B. Right? Now what do I do? Multiply with any constant number. I am multiplying this vector with any constant number to create a new vector Q, vector Q. Okay. So this could be anything. Vector Q is, let's just say, half B vector. So what I will get? 1.5 I cap plus j cap. So where will be 1.5 I cap plus j cap? 1.5 I cap plus j cap will be somewhere here only. Right? What if I multiply with minus 3 by 2 B vector? So that would be minus 9 by 2 I cap, minus 9 by 2 I cap, minus 3 j cap. So minus 9 by 2 minus 3. So that will be somewhere here. Or anything you take, multiply with 4. So that will be 12 I cap plus 8 j cap. Multiply with 4. So this is what you will be getting. Again, what do you understand? That, sir, all the vectors are lying on a single line only. On this single line only, all the vectors are lying. On this single line only, all the vectors are lying. Is that clear to you or not? So all the vectors will lie on this particular single line only. So what do you think, what will be the span? So, sir, span is nothing but one dimensional only. One dimensional only, which can be called as line. Understandable? And what, how many dimensions this vector was having? So this was a two-dimensional vector. This was a two-dimensional vector. So this is a two-dimensional vector which ended up creating one dimension span. A two-dimensional vector has created one dimensional span. Now, sir, how will I find out? Sir, will I be able to, will I have to think again and again? No. What you will do? From this vector, make a matrix. So from this vector 3 I cap, what kind of matrix I can make? What is the rank of this matrix? Sir, there is only one element which is non-zero. Rank of this matrix is 1. So whatever the rank of the matrix you are getting, that will represent the span. What this will represent? This will simply represent the span. Make a matrix out of this vector B. What will be the matrix? 3, 2. What will be the rank you will be getting? Sir, here number of rows are 1. So what will be the rank? This will be the rank. So rank of B is coming out to be, like, what will be the rank? Rank will be 1 only, no? The highest order of the matrix where you can get the highest order of the minor where you can get a non-zero determinant, right? So what is the highest order? That is 1 cross 1 only. So non-zero determinant you required. So what is the rank of matrix B? Rank of matrix B, I hope you know how to find out the rank of matrix B. That is 1 only. So what this is representing? This is representing, that's fine. Someone would say that, sir, why you wrote down in terms of row? I will write down in terms of column. Yes, write down in terms of column. So this will be 3, this will be 2. So I am writing down in terms of column 3, 2. What will be the rank? Here 2 rows are there and 1 column is there. What will be the rank? Rank of B will be 3 only. Sorry, rank of B will be 1 only. Why 1? What is the meaning of rank? Rank means the highest order of the submatrix whose determinant will be non-zero. So what will be the highest order? 1 cross 1 only, right? So what will be the rank of B? That will be also 1. So again this is representing the span. So rank of B is 1, representing the span. Rank of A is 1, representing the span. Rank of B is 1, representing the span only. So take the vector, get its rank, that will represent the span. Similar thing with this one as well. 3i cap plus 2j cap plus 3k cap. In 3D you can show it, right? In 3D I can show this vector 3i cap plus 2j cap plus 3k cap. It will be somewhere here. It will be somewhere like it is in the 3D. Okay, please understand this is in the 3D. So how will I show it? This is how I can show it, that it is in the 3D. So now you are able to visualize that yes sir, it is in the 3D. This point, this is the vector C which is in the 3D. You multiply this vector with anything, let's just say 1 by 2 I multiply with, then what will I get? 1.5 I cap plus j cap plus 1.5 k cap. So where will be that vector? That vector will be somewhere here, right? If I multiply it with some negative value, let's just say minus 4 c vector, so it will be minus 12 I cap minus 8 j cap minus 12 k cap. So it will be somewhere here, like in the same line only. Here I am not able to show it in a good manner. Basically it will be in the same line, right? So how do I show it? This is how I am showing it. All are, this is minus and this is minus, this minus, this minus, and then this one. How do we show? It feels like that this is making some angle. So you are understanding what you are understanding. You are understanding that sir, they will surely be in one line only. And how I can verify that? Create a matrix C. If I create a matrix C, 3, 2, 3. What is the order? 1 row, 3 column. What is the rank of C? The highest order of the square submatrix whose determinant is non-zero. What is the highest order? 1. So what is the rank? 1. So what is the span here? Span is nothing but 1 dimensional. So it was a 3-dimensional vector. It was a 3-dimensional vector. 3-dimensional vector which created a 1D span. This is a 4-dimensional vector. Can you find out its rank? 3, 2, 1, 4. What will be the rank of D? So that will be 1 only. So it is a 4-dimensional vector. 4-dimensional vector which is creating a span of 1D. Span of 1 dimension. Right? So in these 4 examples, what we have done, we are taking only single vector, right? Single vector, vector A, vector B, vector C, vector D. But here I have written set of vectors. So now we will move to taking the set of vectors. So what vector I have taken? 2i cap, and other vector I have taken 3j cap. If I ask you what is the dimension of this vector? What is the dimension of this vector 2i cap? What will be your answer? 1 dimension. No, 2 dimension. Why is that so? Because now you need to consider both of the vectors together. Basically this is a set you are having, no? So 2i cap you are having and the other guy is 3j cap. So this is in the j direction. So what you will say, sir, in I direction magnitude is 2, in j direction magnitude is 0. Sir, in j direction magnitude is 0, sorry, in I direction magnitude is 0 and in j direction magnitude is 3. So both are two-dimensional vector now. Is that clear to you? So I should say two-dimensional vector, two-dimensional vector, two-dimensional vector. So we will see the span. First, can you calculate the rank? If you need to calculate the rank, what you will do? You will create a matrix. Let's just say I create a matrix C. So what kind of matrix it will be there? 2 0 0 3, 2 0 0 3. What is the rank? Rank of C. It is in the row echelon form. So what is the rank of C? Rank of C is coming out to be 2. What does that mean? It will create a 2D span. It will create a 2D span. Along with that, you go to know that they are independent of each other as well. Vector A and vector B are independent of each other. They are set of independent vectors. Set of independent vectors. Now, sir, let's visualize. Give me the visualization, sir. Here you did the mathematics. That you wrote down 2 0 0 3. Sir, I go to know the rank is 2, span is 2D. This is a two-dimensional vector, sir. They are independent as well because we got to know that this is your vector A, this is your vector B. Rank is coming out to be 2. That means they are independent of each other. But sir, mathematics. Give me give me the visualization. Yeah. So let's try giving you the visualization. So this is your 2 I cap, 2 I cap, and this is your 3j cap, 2 I cap, 3j cap. This is your 2 I cap, 3j cap. When I say that span is 2D, when I say the span is 2D, what do I mean? That means using the linear combination of vector A and vector B, you can create any vector in this plane. In this xy plane, if I want to say that I want to create vector, someone comes to me and say that create this vector. What is this vector? This vector is nothing but minus 4 I cap and minus 3 j cap. Create this vector using these two vectors. Only using these two vectors can you create this vector. That means alpha vector A plus beta vector B, I need to make minus 4 I cap minus 3 j cap. Can I do it? Let's try doing it. Alpha into what is vector A? That is 2i. So it will become 2 alpha I plus beta into what is vector B? That is 3 beta j. That should be equivalent to minus 4i minus 3j. So from here, if I compare, I is compared with I. So value of alpha is coming out to be minus 2 and value of beta is coming out to be minus 1. What does that mean? That means your vector C, I am calling this as vector C, or C is given here, no? So let's call this as vector D. So I am saying that my vector D is nothing but minus 2a minus b. So using the linear combination of vector A and B, any vector in the 2D span could be written. Again, let me tell the statement again. Using the linear combination of vector A and B, I can write down any vector in the 2D span. So what is the span here? Span is the plane, or you can say span is two-dimensional. I will give you the visualization as well. 2i cap, 3j cap. Okay. So I have created this simulator. So here I am putting vector u, which is our vector A, which is 2i cap, 2 0 0. So when I only put 2i cap, then it is showing just a line. Okay, I will just simply zoom in. Oh yeah, bhai. So it is simply showing a line. Now if I put 2i cap plus 3j cap, 2i cap not plus 3j cap, basically this is my vector u, which is 2i cap, and this is my vector v, which is 3j cap. So what is the span it is showing? The span it is showing is a plane. Isn't it a plane? So if I write down here, what I have done is that this is the plane we are having. Okay, this was our vector A, which was 2i cap, and this was our vector B, which was 3j cap, and this is the span it is showing, which is a plane, or you can say span is 2D. So if we see a plane, that means span is 2D. Understandable? Very normal visualization. We will see more visualization as well. Okay, so it will be easier for me to explain if I explain it with respect to the visualization. Yeah, so let's see the next example. If the question is coming that vector A and vector B is given, find out the span. Can you find out the span? What you will do? Sir, using vector A and B, I will create a matrix C that will look somewhat like this: 2, 3, 3 minus 4. Sir, I could have written in this manner as well. I could have made a matrix D as well, where I could have written in column format: 2, 3, 2, 3, 3 and minus 4. This also I could have written. In both of the scenario, I will get the same answer. This you know, right? Whether you write down in the row form or you write down in the column form, both will give you the same answers. So 2, 3, 3 minus 4. What is the rank of C? What is the rank of C you are getting? Can you find out the rank? Just multiply this with 3 by 2. You will get to know that rank of C is 2 only. So what is the span? Span is 2D. Span is 2D. That means both are independent of each other. So they were two-dimensional vector. Two-dimensional vector. Two-dimensional vector. Okay. So two-dimensional vector creating a 2D span. Two-dimensional vector creating a 2D span. So let's write down the statements. Here what was the statement? That two independent two-dimensional vector. Did you understand this line first? Two independent two-dimensional vector created a 2D span. All these lines will be interrelated in a great manner later on. Okay, people are just getting confused with these lines only, and you will be able to understand these lines in a very easy manner because we are starting right from basics. So what I am saying, two-dimensional vector, two independent two-dimensional vector, two independent two-dimensional vector created a 2D span. Is that correct? Similar line could be written here as well, that two independent 2D dimensional vector created a 2D span. Two independent two-dimensional vector created a 2D span. This line could be written here as well. Here in the paper, I will not be able to give you the visualization, but with the simulating tool, I can give you the visualization. So let's see the visualization there. So 2, 3, 3 minus 4. What we need to see? 2, 3, 3 minus 4. This will be 2, 3 and 3 minus 4. So you can see this kind of plane we are getting. So this is our vector. This vector is 2i cap plus 3j cap, and you can see this vector is downward, 3i cap minus 4j cap. So 2i cap plus 3j cap this vector, and 3i cap minus 4j cap this vector. So this is the 2D plane we are getting. So what does that mean? Using the linear combination of these two guys, I can write down any vector on this plane. Let's just say someone comes and say that make this vector. Which vector? Make this vector which is lying in this plane. So will you be able to make it? Yes sir. Using the linear combination of this guy and using the linear combination of this guy, using the linear combination of alpha of vector A plus beta of vector B, I will be able to create this vector C, which is lying in this particular plane. Is that clear to you or not? So what is the span? Span is 2D. Although we don't need to do all these things in the examination hall, what we will do, we will simply calculate the rank. But again, visualization are important, that what we actually mean by the 2D span. Is that clear? Absolutely sir, everything is crystal clear. 2i cap, 3i cap. Think about it and let me know what will be the span. Vector A is 2i cap, vector B is 3i cap. Think about it and let me know what will be the span. What you will do? You will create a matrix C. 2i cap and 3i cap. Basically, there is no j cap. So, is it one dimensional vector or two dimensional vector? It is a one dimensional vector only, no? And if you look closely, vector B is simply depending on vector B is simply 3 by 2 times of vector A. So it is not a two dimensional vector, it is a one dimensional vector only, and only one independent vector is there, no? Because vector B is depending on vector A. So there is only one independent vector. So what I will call? This is one dimensional one independent vector. What is the rank that will come out to be? What will be the rank? This is your 2 rows, 1 column. You need to get the row echelon form. How will you get the row echelon form? So this is 2. So what you are doing is that, what kind of transformation you can apply? In row 2, what you are doing? Multiply the row 2 with 2 minus 3 row 1. So 2, 6 minus 6 will be 0. What is the rank you are getting? Simply I can say that rank of C I am getting as 1 only. So what is the span? 1 dimension span only. And it was pretty understandable as well. Why it is understandable? You don't even need the visualization here. You can simply think that's a 2 I cap and then 3 I cap. They are not even independent, no. So it doesn't mean that, sir, if I give you 2 vectors, then you will be able to create 2 dimension space. No. They should be independent of each other and they should be 2 dimensional as well. All these conclusions we will write down. For n dimension we will write down. But are you able to understand the point? Whatever the examples that we are taking, you need to take care of every single example. Here we have taken 2 vectors, but effectively there is only 1 vector. What I said? Effectively there is only 1 vector. That means only 1 is independent. If I give you vector A in your hand, will you be able to write down vector B? You will say yes, sir. If I have 2 I cap, then 3 I cap I can easily write down. Just multiplying it with 3 by 2, I will be able to get 3 I cap. So vector B is not an independent vector. It is depending on vector A only. So you are having one dimensional vector. What is the span you are creating? 1D span. Every single example is important. Okay, let's move slowly. 2 I cap plus 3 j cap, 6 I cap plus 9 j cap. Tell me the span. First, let me know, is it a 2-dimensional vector? Yes, sir, for sure. 2-dimensional vector. 2-dimensional vectors. Make a matrix C which is having 2, 3, 6, 9. What is the rank you will be getting? Apply the transformation. 2, 3. What you will do? R2 will be replaced with R2 minus 3R1. This will become 0 and this will also become 0. What is the rank you are getting? Rank you are getting is, here directly you can see that rank of C is coming out to be 1. What is the span? Span is 1D. Why is that so? Why is that so? Sir, here we are having 2-dimensional vector. How many vectors you are having? Effectively 1 vector only. Why is that so? Because you know that vector B is nothing but a thrice of vector A. So again, there are 2-dimensional vectors, but only 2-dimensional, only 1 independent vector. So using only 1 vector, how you can create 2-dimension space? Let's visualize it. What will be the visualization? 2 I cap plus 3 j cap. Where will be 2 I cap plus 3 j cap? This will be a 2 I cap plus 3 j cap. And where will be 6 I cap plus 9 j cap? So 6 I cap plus 9 j cap will be here. Now I need to use these 2 vectors. What I'm saying is that I need to use the linear combination of these 2 vectors. Linear combination of these 2 vectors, and then I need to create some other vector. Let's just say apart from this line, let's just say I need to create this vector which is 3 I cap. Can you create this vector? Can you create this vector? Using the linear combination of alpha A cap plus using the linear combination of vector A and vector B, can you create 3 I cap? Let's try doing it. Alpha into, this will be 2 alpha I cap plus 3 alpha j cap plus this will be 6 beta I cap plus 9 beta j cap, that will be equivalent to 3 I cap, right? I am multiplying this with beta, this with alpha. So what you are getting? So 2 alpha plus 6 beta I cap plus 3 alpha plus 9 beta j cap, that is equivalent to 3 I cap plus 0 j cap, right? So 2 alpha plus 6 beta should be equivalent to 3. 2 alpha plus 6 beta should be equivalent to 3, and 3 alpha plus 9 beta should be equivalent to 0. 3 alpha plus 9 beta should be equivalent to 0. Is it possible? Is it possible? No, it is not possible, because if you take 2 common from here, from this equation, what do I do? If I take 2 common, what I will get? Alpha plus 3 beta equivalent to 2 will go here, it will become 1.5. And if I take 3 common from here, what I will get? Alpha plus 3 beta from this equation. If I take 3 common, alpha plus 3 beta equals to 0. Is it possible? No value of alpha beta possible. No solution. That means, what does that mean? No solution. What does that mean? There is no such alpha and beta which will make 3 I cap. That means you can only work on this line only. You can only create 1D span. You will never be able to create 2D span. You will not be able to create this vector. You can only work on this particular line. So even if you are having 2-dimensional vectors, still you are not able to create 2D span. In the first example, sir, we were able to create 2D span. Why is that so? Because you were having 2-dimensional vectors. So better I should write down 2-dimensional, 2 independent vectors you were having. 2-dimensional, 2 independent vectors. Right? Here also the same thing. 2-dimensional, 2 independent vectors. 2-dimensional, 2 independent vectors. Understandable? Okay. So all these points, all the conclusion will come up. Have some patience. Whatever that we are learning, that will be useful for you. Somewhere it will be useful and we will make the conclusion as well. But as of now, just keep on looking at the conclusion, whatever that we are writing down. Okay. What you need to remember, how you need to remember, everything will be crystal clear. In the examination, vector A and B is given. They are asking what is the span, what you will do. Find out the span, what you will do. So I will calculate a matrix C. That will look somewhat like this. 2, 3, 5. 3, 4, 6. You will replace R2 with 2R2 minus 3R1. 2, 3, 5. 2R2. So 6, 8, 12. 6, 6, 9, 15. So 0, minus 1, minus 3. This is what we are getting. What is the rank? Rank we are getting is 2. What is the rank we are getting? Rank we are getting is 2. So rank of C we are getting is 2. So what is the span? Span is 2D only. So 2-dimension span we are having. What about the vectors? What kind of vectors you were having? We were having 3-dimensional, 2 independent vectors. 2 independent vectors. We were having 3-dimensional, 2 independent vectors. 3-dimensional, 2 independent vectors. Span was 2D. 1 independent vector. Span was 1D. 1 independent vector. Span was 1D. 2 independent vectors. Span was 2D. 2 independent vectors. Span was 2D. Here 3-dimensional, only here only one vector was there. No? This is one vector only. This is also one vector. This is also one vector. This is also one vector. So as of now, what you feel like that for the span, number of independent vectors are important. If I am able to find out number of independent vectors, then I will be able to tell the span. Dimension is also important, sir. How dimension is important, I will let you know later on. But as of now, you are you are having the surety that if I am having 3 independent vectors, I will be able to create a 3D span. If I am having 2 independent vectors, I will be able to create a 2D span. Dimension is also important. Okay, dimension is also important. How it is important, we will understand that. Don't worry. But as of now, at least this much confidence you are having, that confidently you can say that if I need to create a 2D span, that means at least I need 2 independent vectors. If I need to create a 4D span, I need 4 independent vectors. If I need to create a ND span, then I need n independent vectors. Is that clear? This much surety you are having, right? So shall I show you the visualization for this? Okay, what I fear is that if I come out of this writing pad now, then what may happen is the screen may went off. Sometimes it happens. The software actually sometimes it starts lagging. So I will have to pause the video. Okay, I will have to pause the video, and then I will again open the software, and then I will show you the visualization. Okay. Similarly, you let me know what will be the span here. What will be the span? Think about it, and I will show you the visualization later on. Span here, then let me know the span here as well, and let me know the span for this one, then I, this one, then yes. So these span you let me know, and I need to show you the visualization that how it is representing 2D. Although sir, it is a 3-dimensional vector, so how it is representing 2D? That visualization I need to show you, but for that I will have to pause the video. Okay, so I will remember 2 3 5 3 4 6 2 3 5 3 4 6. Okay, so let me pause the video and then I will show you the visualization. Yeah, hi guys, welcome back. Sorry for the interruption. Actually, I tried simulating it, or I tried visualizing it, but it is throwing an error. As of now, it is throwing an error. This particular example is throwing an error. I can show you some other example. Okay, let's see some other example. Let's just take 2 3 4 2 3 4. Okay, and then let's take 3 7 2. Are they independent of each other? 3 7 2 3 4 3 7 2. Yes, you can check they are independent of each other. So two vectors are there. Two 3-dimensional independent vectors are there, which are creating a plane. You can check, right? It is a plane only. So two vectors are creating a 2D span. Two independent 3-dimensional vector. What I am going to write down? 3-dimensional, two independent vectors are creating a 2D span. Is that clear to you? Understandable? Let's take the next example. 2 3 4 4 6 8. Let me know what will be the span. What will be your answer? Are they two independent vectors? Absolutely not, sir. I can directly see that vector A is nothing but vector B divided by 2. So effectively this is only one independent vector, or I would say one. Here what is the language you are writing? So first we are writing down the dimension. So three-dimensional one independent vector. What will be the span? Span will be 1D only. Why is that so? Because we can create a matrix C. What that would be? The matrix C would be 2 3 4 and 4 6 8. I need to find out the rank, sir. So what I will do, I will apply some particular operations. Using those operations, I will get to know that the second row I will get all 0 row. I can simply know that R2 minus 2R1 will throw all 0 row. So 2 3 4 0 0 0. So it will be a all 0 row. So rank of C is coming out to be 1. What does it show? It show the 1D span. So again, what you can notice here? What you can notice? You can notice one thing, and that thing is one independent vector. One independent vector is creating a 1D span, right? Two independent vectors creating a 2D span. One independent vector creating a 1D span. One independent vector creating a 1D span. So n independent vector will create a ND span. But sir, what about the dimension? As of now, we are not commenting anything on the dimension, but dimension will also play an important part that we will see slowly. But as of now, you are pretty sure that the number of independents that you are having, the number of independent vectors that you are having, it will create the same kind of span. Understandable? Let's go to the next question. 2i cap, 3j cap, 5k cap. First, let me know what is the dimension of A, B, C vector. So they are the set of vectors, sir. One is in the I cap direction, other one is in the j cap direction, and other one is in the k cap direction. So actually, sir, it could be written as 2i cap, 0j cap, and 0k cap, because it is not a single vector, they are the set of vectors. So that's why I will write down in this manner that 0i cap plus 3j cap plus 0k cap, and 0i cap plus 0j cap plus 5k cap. And if I make a matrix D from these vectors, you can either take them as a row or you can take them as a column as well. It's up to you. The way you want to show them, you can show them. So I am showing them as a row. So 2 0 0 0 3 0 0 0 5. First let me know, is it in the row echelon form? Absolutely sir, it is in the row echelon form only. And how many non-zero rows you are having? I am having 3 non-zero rows. So what does that mean? So what is the span? Span is nothing but 3D. And if the rank is coming out to be 3, what does that mean? That means all 3 are independent of each other. So there are 3-dimensional, first you are writing down the dimension. So 3-dimensional, 3 independent vectors. 3-dimensional, 3 independent vectors will create what? 3-dimensional, 3 independent vectors will create a 3D span. 3-dimensional, 3 independent vectors is creating a 3D span. Is that understandable to you or not? Sir, visualization. So it is 2 0 0 0 3 0 0 0 5. 2 0 0 2 0 0, right? Then 0 3 0 0 3 0, and then 0 0 5. And you can see that this green, you can see it is a space, right? Sorry, not green, whatever the color is, yellow color is there. So this is the space they are creating. So in this particular space, whatever the vector I want to frame, I will be able to frame that vector. What I mean to say is that if someone says that I want to create this vector using the linear combination, I want to create this vector which is 3i cap plus 4j cap plus 2k cap. Can you create it? Then you will say, yes sir, I will take vector u, I will multiply the vector u with 3 by 2 plus, then I will take vector v, I will multiply the vector v with 4 by 3. Then I will take vector w and I will multiply the vector w with 2 by 5. 2 by 5. So try taking it. What is vector u? Yeah, what is vector u? Vector u is 2i cap. So 3 by 2 multiply with 2i cap, what you will get? 3i cap plus. What is vector v? Vector v is nothing but 3j cap. So 4 by 3 multiply with 3j cap, what you will get? 4j cap plus 2 by 5 multiply with 5k cap, what you will get? 2k cap. Are you getting the same vector? Yes sir, we are getting the same vector. So using the linear combination of all these 3 vectors, I can create any vector in the 3D span, or the 3D span is having a better name. We call it 3D space as well, or you can call it 3D span or 3D space, whatever the name you want to give, you can give it. But in language, we will say the span is 3D. I hope it is absolutely understandable to you. Okay, the screen is lagging. Charger is also on. Everything is fine, but still it is lagging. I don't know why. Yeah, let's go to next example. So this is example H we are having. 2i cap plus 3j cap, 3j cap plus 4k cap, 2i cap minus 3j cap plus 2k cap. So how will I make the matrix D? And then I need to find out the rank. And visualization also we can see based on the rank that we are getting. So 2 3 0 0 3 4 2 minus 3 2. Okay, so let's check the rank of D I need to calculate. So what I will do is that I am directly calculating the determinant of D. If it is coming out to be non-zero, then I would know that rank is 3, otherwise the rank would be 2, right? Because rank will be surely 2, no? Because if you take this matrix only, so 3 into 2 will be 6, 6 minus 0 will be 0 only. So at least 2 rank would be there. But let's check if the rank is 3 or not. So what I am doing is that I am simply calculating the determinant. So I hope the concept of determinant is clear to you. Plus 2, 12. So surely it will come out to be non-zero. What I did, I am just calculating the determinant with respect to column 1. So 2 multiply with 3 into 2, 6, 6 minus minus 12. So this will become 6 plus 12 plus this value 2. So 2 multiply with 4 into 3, 12, 12 minus 0 will be some value. So basically this will be a positive value and this will be non-zero. What does that mean? Rank of D is coming out to be 3. And what is the meaning of rank being 3? That means they are 3-dimensional, 3 independent vectors. And they will end up creating 3D span. So till this point, again another point you are making, that sir, if we need ND span, if we need ND span, n dimensional span, what does that mean? We will need n independent vectors, n independent vectors. This much is clear to you. To get a ND span, you need n independent vectors, or otherwise also you can say that n independent vectors will create ND span. Both direction you can say that 3D span is there, 3 independent vector is there. Are you able to understand this point? 3 independent vectors, 3D span. These numbers are always equal. 3D, 3, 3, 1, 1, 2, 2, 1, 1, 1, 1. Right? 2 independent, 2 independent. But here you see 2 dimensional. This number is changing. 1 dimensional, 2 dimensional, 3 dimensional, 3 dimensional. So again and again you are getting only one doubt, that sir, what will happen to the dimension of a particular vector? We have understood that sir, 3 independent vectors will create 3D span, 2 independent vectors will create 2D span, 1 independent vector will create 1D span, 4 independent vectors will create 4D span, 5 independent vectors will create 5D span. Right sir? But what is the meaning of a 3 dimension, 2 dimension, 1 dimension? That we will see just after one more example. This is one more example. So let me know what is the rank here. 2, 3, 4, 3, 4, 3, 6, 8, 6, 8, 6. Yes. So let's find out that rank. So I will create another matrix D, which will look somewhat like this. Two, 3, 4, 3, 4, 3, 6, 8, 6. Right? So shall I apply the transformations, or I can directly see something? Let's apply the transformations. Okay. So what I will do is that I will apply the transformation. R2 is being replaced with 2R2 minus 3R1, and R3 will be replaced with R3 minus 3R1. Why is that so? To create a 0, 0. Right? So R1 remains as it is. So this will be multiplied 6, 8, 6, and this will become 4, 6, 8. So this will become 2, this will become 2, and this will become minus 2. And what about this? Sorry guys. So second row was multiplied with 2. So 6, 8, 6, and first row was multiplied with 6. So this will become 6. First row was multiplied with 3. So 3 into 2, 6, 3 into 3, 9, and this will become 12. So 0, minus 1, minus 6. Okay. And now what about 3R1? So this will become 0. And I just need to round 6, 8, 6. So this will become 0, this will become minus 1, and this will become minus 6. Right? So here also what did I notice? These two rows are same, so you can simply subtract row 3 from row 2. You will get to know that rank of D is coming out to be nothing but 2 only. So although it feels like that there are 3 vectors, but there are only 2 independent vectors. So 3 dimensional 2 independent vectors. Will end up creating 2D span. Right? So again 2 independent vectors will create a 2D span. Shall we do the visualization? 2, 3, 4, 3, 4, 3, 6, 8, 6. 2, 3, 4, 3, 4, 3. 2, 3, 4, 2, 3, 4, 3, 4, 3, 3, 4, 3, and next is 2, 3, 4, 3, 4, 3, 6, 8, 6. 6, 8, 6. There you go. It is coming out to be a plane only, right? You can see it is coming out to be a plane. So there are 3 dimensional 2 independent vectors. Only 2 independent vectors are there. So The span is only 2D. What is the span? Span is only 2D. Understandable? Okay. Now this is the question for you. Using a set of one-dimensional vector, what you need to do? Using a set of one-dimensional vector. What does that mean? That means I am having this kind of set. In this set, I am having vector 1, vector minus 1, any vector you can take. Vector 2 by 3, vector 7 by 5, vector minus 3. Any one-dimensional vector you can take. Is it one-dimensional? Yes, sir. 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 So using a set of one-dimensional vector, you need to create a 2D span. You need to create a 2D span, and you can use any number of a one-dimensional vector. What does that mean is that, let's just say I am creating a set. This is, I am creating my first set. I have created the set of vector A, which is 2 I cap, vector B, which is 3 j cap, and vector C, which is not j cap. I cannot take j cap. I need one dimensional vector only, no? So 3 I cap only here as well, and here minus 2 by 3 I cap. So is it a set of one dimensional vector? Why they are one dimensional? Because this is also in I cap, I cap, I cap, so there is only one dimension. So is it a set of one dimensional vector? Yes, sir. Now I need to see the span. For getting the span, what I will do? I will create a matrix 2 3 minus 2 by 3. Let me know what will be the rank. This is your 3 cross 1. What is the rank of D? 1 only. What does that mean? What does that mean? What is the span? 1D span. What you need to create? You need to create 2D span. You need to create 2D span. Let's just say I was not satisfied with this example. I took another example. Let's take a set of 5 vectors this time. So vector A I am taking as 2 I cap, vector B I am taking as 3 I cap, vector C I am taking as minus 2 I cap, vector D I am taking as 3 by 2 I cap, vector E I am taking as 9 I cap. Let me know how many independent vectors you are having. Are they set of one dimensional vector? Yes, sir. Set of one dimensional vectors. We are using 5 one dimensional vector. We are using 5 one dimensional vector. But eventually there is only one independent vector, no? You can say that, sir, vector B is depending on vector A, vector C is depending on vector A, vector D is depending on vector A, and vector E is depending on vector A. So there is only one independent vector. What I mean to say is that creating 2D span using one dimensional vector is not possible. Again, creating 2D span using one dimensional vector, no matter even if you use 1 vector or 2 vector or 3 vector, 4 vector, 5 vector, 7 vector, 1000 vector, if you are using one dimensional vector, you can never create a 2D span. Why is that so? It is pretty obvious, no? What I will do, I will make a matrix F. In matrix F, what I will write down? I can make row wise, no? So in matrix F, I will write down 2 3 minus 2 dot 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 1000 element I have written. Okay, how many elements I am writing down? 1000 element I am writing down. So this is the matrix I will make. 2 3 minus 2 in that manner. 1000 element I am writing down. 1000 vector I have taken. So what will be the order? 1 row and 1000 columns. Let me know the rank of F. What will be the rank? Rank is always the minimum number of m cross n, that will be 1 only. So rank of F will come out to be 1, but that means there will be only one independent vectors. That means you will be able to create 1D span only. So in all the previous example that we have taken, just notice one thing, that this value will always be greater than this value. 3 is always greater than 2. 3-dimensional vector is creating a 2D span. Either it will be greater or it will be equal. Either it will be greater or it will be equal. So let's check. 3-dimensional vector is creating a 3D span, equal. 3-dimensional vector is creating a 3D span, equal. 3-dimensional 1D span, either it is greater or equal. 3-dimensional 2D span. But it can never happen that you are having 3-dimensional vector, okay, and you are creating the 4D span. No matter even if you take 1000 vectors, you can never create it. What does that mean? That means using n-dimensional vectors, I can create maximum ND span. Maximum. I can create maximum ND span. And what is the meaning of this maximum ND span? The meaning of this maximum and this span is that I can have maximum n independent vectors. Maximum n independent vectors. Did you understand this point or not? A very confusing point, people will just simply mug up, but now everything is crystal clear. A very simple point it is, but just because of the language, people will struggle. N dimensional vectors, using a set of n dimensional vectors. I am using 1000 n dimensional vectors. Maximum span that I can create is ND span only. So if the span is ND, what does that mean? That means you can have maximum n independent vectors. We have understood this with the one dimensional example, like I framed this question and we understood. Similar question I am framing for two dimensional as well, that you are having a set of two dimensional vector. That means this kind of set you are having 2i cap 3j cap minus 2i cap 4j cap, right? 3i cap 2j cap, 2i cap 0j cap, and so on. That means I am saying that I am having what I will take. This is the example A I am taking, that 2i cap plus 3j cap, this is one vector I am taking, this is another vector I am taking, using the set of two dimensional vector, using a set of a two dimensional vector, 3i cap plus 2j cap, and then vector C I am taking as minus 2i cap plus 4j cap. So I am using three two-dimensional vector, but let me know effectively how many independent vectors are there. So what I will do, I will create a matrix D and I will calculate its rank. 2 3, let's write down column wise. Okay, you can write down anyway. 2 3, 3 2, minus 2 4. Let me know what is the rank of this. This is your 2 rows 3 column. When you calculate the rank of D will come out to be 2. That means out of them only 2 are independent, third one is dependent. Only 2 independent vectors are there. So you are using two-dimensional vectors, but ended up getting only 2 independent vectors. And that will end up creating 2D span. You have to listen to my words carefully, otherwise you will not understand anything in the whole video. And if you are listening to my words carefully, then you are understanding everything. If you feel like that, sir, I am not understanding anything, leave the video. And if you are someone who is still in the video, that means you are understanding everything. Okay, I am asking a question that I am giving you 4-dimensional vector set. Okay, 4-dimensional vector set. In this 4-dimensional vector set, you are having 5 vectors. Out of these 5 vectors, tell me the maximum number of independent vectors. I am giving you 4-dimensional set of vectors. Okay, in this vector set, you are having 4-dimensional vector. That means I cap plus j cap plus k cap plus l cap. This kind of vectors you are having. A I cap plus B j cap plus C k cap plus D l cap. This kind of vectors you are having in this set. And how many vectors you are having? 5 vectors you are having. Out of these 5 vectors, how many vectors could be independent of each other? Maximum number you tell me. So using a 4-dimensional set, I can get maximum 4 independent vectors. Using a 2-dimensional set, I can get maximum 2 independent vectors. Using a 1-dimensional set, I can get maximum 1 independent vector. Using 3-dimensional set, I am getting 2 independent vectors. That means maximum I can get 3. Using a 3-dimensional set, I can get maximum 3 independent vectors. 3-dimensional, maximum 3 independent vectors. You will never see that, sir, n-dimensional, but n plus 1 independent vectors. This will never happen. No matter how many vectors you use. Even if you use 1000 vector, 2000 vector, 2 lakh vectors, whatever the dimension is given, that is the maximum number of independent vectors you can have. This point is, sir, absolutely clear. What is the meaning of dimension of a vector? What is the meaning of number of independent vectors? What is the meaning of number of vectors in my n dimension set? Everything is crystal clear, sir. Word to word, point to point. I will never get confused in the language. I will never get confused in the question. Okay? Because in 9 out of 10 places, the topic will not even be taught. Okay? What I am saying is that out of 9, out of 10 places, in 9 places this topic they will not even teach. At one place they will teach and they will make it completely mathematical or theoretical, that this statement is there, this statement is there. People understand nothing. They just learn the problem solving approach, that this is how we will solve the problem, and that's it. We will solve the problem of vector space with zero work. You will see the problem, you will understand it, without even using the pen you will get the answer. Otherwise you see the solution, we will give the solution in 4 pages, that this is how you need to write down, then alpha beta multiply, then rank you calculate. Without even using the pen we will tell the answer, I am telling you. And the same questions have appeared in GATE examination, and you see their solution. Their solution would be in 4 pages. Okay, so that's why I am building up this base, because this particular topic was my like favorite topic. Here I need to prove that why this content is different. I hope you are able to understand. So here only differentiator would come, no? Like everyone is teaching engineering mathematics, so how this content is different? When I am saying that I will bring something different, how I am bringing it different, that I am telling here. Okay, so I hope you are able to understand. More things would come up, certainly more conclusions also we will make. Sir, where all these conclusions would be written? If you want to write down in your way, then I am giving you free space, right? Here a lot of free space are there, so in your way you can write down the conclusion in your own language. I will write down the conclusion later on in more mathematical way. Okay, conclusion will be written later on, but as of now, what all conclusion we have made? If we are having n independent vectors, can we create n dimensional span? Yes. If we are having 2 independent vectors, 2 dimension span. If we are having 4 independent vectors, 4 dimension span. If we are having 7 independent vectors, 7 dimension span. Now, independent vectors and dimension of the vector, what is the relation? The relation is that if I am having the dimension of the vector as n, if I am having the dimension of the vector as n, then maximum I can get n independent vectors. Maximum I can get n independent vectors, and that will end up creating ND span. Understandable? Maximum I am saying again and again, maximum I am saying. Now I am having n dimensional vector. Can I get n minus 1 span? For sure. I am having n dimensional vector, n dimensional vectors, n dimensional vector. So let's just say I am having n dimensional only 2 independent vectors. So what will be the span? 2D span. So span will depend on the number of independent vectors. Span will depend on the number of independent vectors, and number of independent vectors are depending on the dimension. Everything is crystal clear. Again and again repeating the statement, and absolutely everything is clear. Understandable? Let's see the meaning of R1, R2, R3, Rn. So these kind of things would be written R1, R2, R3. They will say that your vector, your set of vectors belongs to R1. What is the meaning? Meaning of R1 is one dimensional set of vectors whose coefficients are real. Whose coefficients are real. What does that mean? What is R1? Sir, R1 is nothing but this. This is R1 only. What was R1? This was R1. So here I have written the language using a set of one dimensional vector. There what they will write down? Vector space R1. What they will write down? Vector space R1. What do you mean by vector space, sir? Set of vectors. Set of vectors combined is known as vector space. What I am saying is that set of vectors. Set of vectors. This wording is known as vector space. So in the examination they will write down vector space R1. What you will understand from here? That they are talking about the set of one dimensional vectors whose coefficient are real. So set of one dimensional vector. One dimensional vector. Set of one dimensional vector whose coefficients are real. Next, set of two dimensional set of, I should have written better language, set of one dimensional vector, right? Set of one dimensional vector, right? Set of one dimensional vectors. This is a better language, right? So what is set of vectors? Set of vectors is known as vector space. Set of vectors is known as vector space. set of one dimensional vectors. Okay, in this set one dimensional vectors are present. Understandable? What do you mean by R2 then? Set of two dimensional vectors. Two dimensional vectors whose coefficients are real. R belongs to real. Okay, what is the meaning of this R? R means real. And what is the meaning of this one? Dimension. So what will be your R2? R2 will be, in R2 1 2 would come up, 3 4 can come up, then -2 -1 could come up, then -1 -3 by 2 could come up, then -1 4 could come up, and this kind of infinite vectors would be there. Again I am asking you one more question. Out in this set, how many independent vectors you are having? How many independent vectors you are having? Only two independent vectors. Only two independent vectors. How you can say so? Sir, if I make the matrix 1 2 3 4 -2 -1, and in that manner it will keep on going. So there will be two rows, and let's just say there are 1 lakh or whatever it is, 1 lakh columns are there. But what will be the maximum rank I will get? Maximum rank I will get is 2. Maximum rank of this matrix, let's just say it is matrix D, that I will get is 2. That means there is maximum 2 independent columns. That means maximum 2 independent vectors I can get. Rest all will be dependent. Understandable? So if I am having 2 dimension vectors, if I am having the set of 2 dimensional vectors, then maximum I can get 2 independent vectors only. This line we have written, right? If we are having a set of 2 dimensional vectors, no matter how many vectors we take, here I will write down in this manner as well, A, B, C, D, E, F, and so on. In that manner, I am creating 2 rows and n columns. N could be anything, but still the rank I will get, maximum rank I can get is, maximum rank I can get is 2 only. So maximum possible rank is 2 only. What does that mean? That means maximum I can get 2 independent vectors. So similar thing I have explained here. Similarly, if I write down R3, what does that mean? Set of 3 dimensional vectors whose coefficients are real. And what is the meaning of set of n dimensional vectors whose coefficients are real? So set of all, there is another word, set of all one dimensional vector. When I am saying R1, that means I am assuming all the one dimensional vector. In this set, all the one dimensional vectors are present. Here all the one dimensional vectors are present. Okay, when I am saying R1, that means set of all possible one dimensional vector. Sir, this is one dimensional vector, this is one dimensional vector, there could be infinite one dimensional vector. So when I am saying R1, that means all the vectors would come. So I am asking you, in R1, how many independent vectors you are having? So you will say I am having one independent vector. In R1, I am having one independent vector. You will not say, sir, maximum one independent vector I can have. No, you will say I am having one independent vector. Why is that so? Because here all the vectors would come up, no? All the 2-dimension vectors would come up. Every possible 2-dimension vector would come up. Right? Every possible 1-dimensional vector, every possible 2-dimensional vector would come up. So here every possible 2-dimensional vector would come up. Then how many independent vectors you will have? 2 independent vectors you will have. 2 independent vectors you will have. Right? You will not say, sir, maximum 2 independent vectors. No, I will have 2 independent vectors for sure, because all the vectors will come up. No, so here this word is also important. All, set of all 1-dimensional vector, all 1-dimensional vector. Okay, set of all n-dimensional vectors, set of all n-dimensional vectors whose coefficients are real. Okay, so this word is important, all the vectors. So what about R3? R3 would be written somewhat like this. Sir, I can have 1 2 3. Sir, I can have 2 4 6. I can have 3 6 7. I can have -1 2 -3, and so on. Now someone would say that, sir, 1 2 3 and 2 4 6 are depending on each other. Yes, they are depending on each other, but these two are independent. These two are also independent. So how many independent vectors you will have? I will have 3 independent vectors. 3 independent vectors. Okay, so in R3 I will have 3 independent vectors. In R2 I will have 2 independent vectors. In R1 I will have 1 independent vector. That's for sure, because it is a set of all possible 1-dimensional vector. All possible. Right? Understandable? Let's solve this question. a set of vector is defined as V x y z, x belongs to R, y belongs to R, z belongs to R. So what is V? Can you let me know what is V? V is nothing but R3 only. X, Y, Z all are real. So V is nothing but R3. So 1, 2, 3, 2, 3, 1, minus 1, minus 2, 3, 2, 4, 7, and so on. Find the maximum possible number of independent vectors from this set. This language is wrong. Here I should write down. Find the possible number of, find the number of independent vectors. Find the number of independent vectors from this set. Why is that so? Because this is a set of infinite elements. In this set, infinite elements would come up. All possible elements would come up. All possible. Not infinite, I should say all possible. All possible 3-dimensional vector. All possible 3-dimensional vectors. 3-dimensional vectors would come up. All possible 3-dimensional vectors are coming up. And if all possible 3-dimensional vectors are coming up, what does that mean? That means the rank will be 3. Why is that so, sir? You will create a vector, you will create a matrix D, there you can write down 1, 2, 3, 2, 3, 1, right? Minus 1, minus 2, 3, 2, 4, 7, alpha, beta, gamma, A, B, C, and so on. In that manner, 3 rows and n columns. What will be the rank? Rank you will be getting is, rank I will be getting is that I will be having 3 independent vectors. Because here I am talking about all the vectors, no? All the vectors. Someone would say that, sir, here you wrote 3-dimensional vector, but eventually your independent vectors were 2, which were less than 3, no? You are having 3-dimensional vectors, but your rank was 2. But here I am only having 3 vectors, no? They are not all possible 3-dimensional vector. Are you able to understand this point? I am having only 3 vectors. This is the set of only 3 vectors. This is not a set of all possible 3-dimensional vector. In the set of 3 vectors, I may get only 2 independent vectors. What I mean to say is that, let's just say I create a set like this. 1, 2, 3, 2, 4, 6, and 3, 6, 9. This is my set. Okay? And so on. And the set is something like this: x, 2x, and 3x. First number is double of second, second number is double of first, and third number is triple of first. So here also 2, 4, 6, 3, 6, 9. So this is the order it is being followed. So this is the set we are having. Is it a set of infinite elements? Yes, sir. There are infinite elements. There is this vector 1, second vector, third vector, fourth vector, fifth vector, sixth vector. So there will be infinite vectors like that. 1, 2, 3, 2, 4, 6, 3, 6, 9, 4, 8, 12, 5, 10, 15. In that manner, a lot of vectors would be there. But you know, sir, one thing you surely know. What do you know? That, sir, there is only one independent vector. Why is that so? Because this vector could be written in the language of this vector. Because your second vector is simply the twice of a first vector. Your third vector is simply the thrice of first vector. Your fourth vector will simply be the 4 times of a first vector. Your nth vector is simply be the x time of a first vector. Are you able to understand this point? So how will I write down the language of this vector? I will write down the language of this vector as, this vector is nothing but R1, but there is a condition that y is 2x and z is 3x. Y is 2x, z is 3x. But here there is no condition. You can take any number. X you can take any number, y you can take any number, z you can take any number. So all possible 3-dimensional vector I am having. That means what will be the rank I will be getting? I will be getting the rank to be 3. That means I will have 3 independent vectors, and that means I will be able to create a 3-dimensional span. Is that clear to you? Okay, but sir, what if there are conditions? If there are some condition involved, then yes, your span may reduce. If there are some condition involved, then your span may reduce, but there is no condition, any real number you put, that means yes, all possible vectors I will have. So maximum I can get 3 independent vectors. So what will be my rank? Rank will be 3, and I will have the span to be 3D. So what will be the span of this vector space? Set of vector means vector space. So what will be the span of this vector space? The span of this vector space will be 3D. 3D span I will have. Is that clear? Okay, let's go to the next question. So this question is saying x, y, z belongs to R3, y is equals to 2x, find the span of V. What I need to do? I need to create a vector V. In vector V, what all element could come? If I say x is 1, then can I take any random y? No, y has to be 2. No, what is the condition given? Y equals to 2x is given. So y has to be 2. There is no other chance. So y has to be 2. Can I take any random z? Yes sir, z anything random you can take. If I am saying that my x is 0, then y has to be 0. There is no other chance. But z anything random you can take. If I say my x is -1, then y has to be -2. But here you can take anything random, 3. Similarly, if I take x as 3, then y you have to take as 6, and this anything random I can take, and so on. This will be the scenario. This will be my vectors. This will be my vector space V, right? What will be the rank? Let's just say I take only those 4 elements. How many elements it will have? Infinite elements it will have. But let's just take a smaller set of elements. I'm only taking 4 elements, and I'm creating a matrix D. What will be the rank that will come out to be? You will see that. Oh, can I write down in terms of row? Okay, whether you write down in terms of columns or you write down in terms of row, both will be the same thing, but I am writing down in terms of row. 1, 2, -1. This was my first vector. Then I am writing down 0, 0, 1. Then -1, -2, 3. Then 3, 6, 7. Let me know what would be the rank. What do you think? What will be the rank? Sir, the maximum rank that I can get is 3. But will I get the rank 3? Maximum possible is 3. Why is that so? Because sir, 4 rows are there, 3 columns are there. Maximum possible is 3. But will I get the rank to be 3? Let's check that out. You will see something interesting, that sir, rank is not coming out to be 3. Why is that so? Let's check it out. So what I will do, let's keep this one as it is. I will keep this row in the last. Okay, and then in row 3 what I am doing? Row 3 is simply added with row 1. And in row 4 what I am doing? Row 4 is being subtracted from thrice of row 1. So what you will be getting? -1, 2, -1. This, let's keep this as 0, 0, 1. And here I am simply adding 0, 0, 2 I am getting, and then subtracting thrice. So 0, 0, and this will become 10. Right? Now next what I will do? Directly you can sense what I am going to do is that R3 will be replaced with R3 minus 2R2, right? And R4 will be replaced with R4 minus 10R2. So what you will end up getting? You will end up getting last 2 rows as 0, 0. This will be 1, and here from here twice will be subtracted, and from here 10 times will be subtracted. What is the rank you are getting? Here you are having 2 non-zero rows, so rank of D is coming out to be 2. What does that mean? We are having only 2 independent vectors. 2 independent vectors. How many independent vectors we are having? Only 2 independent vectors we are having. So sir, it was R3. So you said that sir, in R3 you will have 3 independent vectors, but there is a condition involved, y equals to 2x. So what really happened? First you thought that sir, there are 3 elements, x, y, z. Will you call it 3-dimensional vector? Will you call it 3-dimensional vector? Yes sir. Is it a 3-dimensional vector? Yes sir. Is it a 3-dimensional vector? Yes sir. Is it a 3-dimensional vector? Yes sir. But because of this condition, effectively it has become 2-dimensional vector. Effectively. What do you mean by effectively 2-dimensional vector, sir? Let's check that out. So what was our vector? Let's just take vector A. Our vector A was xi cap plus yj cap plus zk cap. This was our vector, right? Now what is given? Y equals to 2x is given. So what my vector A would become? Xi cap plus 2xj cap plus zk cap. Can I take x common? Yes sir. I cap plus 2j cap plus z k cap. Isn't it a vector itself? I cap plus 2j cap. Let's do one thing. Divide it by under root 5. Basically, I am dividing it by its magnitude. What will be the magnitude of 2j cap plus I cap? 2j cap plus I cap. That will be under root 2 square, that is 4. Under root 1 square, that will be 1. So I am dividing it by under root 5 and multiplying it with under root 5 as well. This is my vector A. So can I write down this as another vector L cap? Can I write down in this manner? Under root 5x L cap plus z k cap. So this is my vector A is coming out to be. And how many dimension it is having? Only 2 dimension it is having. So I cap plus 2j cap divided by under root 5. Here I multiply with under root 5. And someone would say that, sir, I cap plus 2j cap under root 5. Here, sir, I can say one thing, that I cap, j cap and k cap are I cap, j cap and k cap are orthonormal to each other. So I will say yes, these guys are also orthonormal to each other. What you can say is that I cap plus 2j cap divided by under root 5 is orthonormal to k cap for sure. This is the condition is also satisfied. Okay, so satisfying all the condition, I go to know that it has become a 2-dimensional vector only. So another new point we have understood here, that sir, if any other variable is having some condition, if this variable is depending on this variable, that means effectively you have killed this variable. Effectively you have made only one variable. So if these two variables have become one variable, what does that mean? Effectively it has become a 2-dimensional vector only. If you are having 2-dimensional vector, that means the maximum number of independent vectors you can get is 2. So what will be your span? Span will be 2D. So although it feels like that, yes sir, there are 3-dimensional vectors, but effectively in your mind you would remember that they are not a 3-dimensional vector, they are 2-dimensional vector only. Is that understandable to you? A very, very important conclusion, a very intuitive. Find out any textbook, find out any lecture where this kind of explanation is given. They will solve it with respect to mathematics. Everyone would solve it with respect to mathematics, but we have built up the intuition taking the example as well. Along with that, we have taken mathematics as well, and we have understood that this is a 3-dimensional vector space. I would surely say that yes sir, it is a 3-dimensional vector space. 3-dimensional vector space. But effectively, effective dimension, 3-dimensional vector space which is having 2 independent vectors. 2 independent vectors. 3-dimensional vector space which is having 2 independent vectors. Why it is having 2 independent vectors? Because sir, effective number of dimension it is having is only 2. So effective number of dimension it is having 2, and infinite elements would be there. Infinite vectors would be there. So I will get maximum 2 independent vectors only. So what will be my span? Span will be only 2D. Is that clear to you or not? I hope it is clear. Okay. This question I will give you. Find out the span of V in one line without even doing any calculation. Let me know what will be the span of V. Option are given: 1D span, 2D span, 3D span, 4D span. Sir, R3? Answer is 3D. Absolutely not. Y is depending on X. Z is depending on X. What does that mean? That means you have killed 2 variables. Only variable left is that is X. What does that mean? Is that you are having a vector A which was X I cap plus Y j cap plus Z k cap. This is looking very easy. Let's do one thing. Let's make it X plus Y plus Z equals to 0. Okay. What I am making? X plus Y plus Z equals to 0. This is the condition is given. 2 conditions are given. First one is Y equals to 2x, and second one is X plus Y plus Z equals to 0. So Y could be written as 2x. So this will become 3x plus Z equals to 0. So effectively it is given that Z equals to minus 3x. So 2 conditions are given: Y equals to 2x and Z equals to minus 3x. So sir, this was my vector, but eventually your vector has become so what you do, you take X common, then I cap plus 2j cap minus 3k cap divided by the magnitude, and then multiply with the magnitude. 9 plus 4, that will be 13 and 14. So under root 14. So what we are getting? Under root 14 x L cap. So this is the vector A you are having. So effectively it has become one dimensional vector only. So what is the maximum span you can get? The span you can get is 1D span. What will be the answer? What is the answer? Span of V is 1D span. Now sir, all these things I don't want. I want to go with more calculation. Then this is how you can do the calculation. If you take x equals to 1, are you free with y? No, y has to be 2. Are you free with z? No, z has to be minus 3. If you take x equals to 0, are you free with y? No. Are you free with z? No. If I take x equals to minus 1, are you free with y? No. Are you free with z? No. If I take x equals to 2, are you free with y? No. Are you free with z? No. And so on. Then what I will do? I will create a matrix D. I am creating it row wise. Okay. 1, 2, minus 3. Then I am having 0, 0, 0. Then minus 1, minus 2, 3. And then I am having 2, 4, minus 6. What do? I apply the transformations. What transformation I will apply? That sir, R3 will be replaced with R3 plus R1. And R4 will be replaced with R4 minus 2R1. What you will end up getting? First one remains as it is. 1, 2, minus 3. This is 0, 0, 0 only. R3 plus R1 you do. 1 plus minus 1 plus 1, 0. Minus 2 plus 2, 0. Minus 3 plus 3, 0. And twice of this you will subtract 0, 0, 0. What is the rank of D you are getting? Rank of D we are getting is nothing but 1. What does that mean? It is having 1D span only. So if such kind of a condition are written, will you be able to understand that what will be the span? Yes sir, it will be having only 1D span. That means it will create a line. This will create a plane. This will create a plane. And this will create a 3D space. Is that clear to you or not? Everything is crystal clear. Let me tell the conclusion what all things we have studied. Started right from the beginning, we got to know that if we are having n independent vectors, then I can create ND span. Right? Is that clear? Let's write down the conclusion here. Okay, I will add up this page later on. What I do, although all the conclusions are written, but as of now, let's write down the conclusion in short manner. In what manner? Short manner. So first conclusion, the very first conclusion, that if you are having n independent vectors, what you will end up creating? You will end up creating ND span. Now, if you are having n dimensional vector space, I could have written down set of vectors or vector space. So if I am having n dimensional vector space, then maximum I can create n independent vectors. And if I am able to create n independent vectors, that means maximum I can have ND span. Secondly, if I am having n dimensional, if I am having vector space of all possible n dimensional vectors, if I am having vector space of all possible n dimensional vectors, that means without any condition n dimensional vectors. What do you understand from this? That without any condition, here sir there was a condition that here 1, 2, minus 3 can only come. Someone would say that sir, can this vector come here? 1, 4 and minus 3, can this vector come? No, because y has to be equal to 2x. So this vector cannot even come. In this vector space, this vector cannot even come. 1, 4, minus 3 cannot even come. So it is not the set of all 3-dimensional vectors. So what I will say, this is not a set of all possible 3-dimensional vectors. Few 3-dimensional vectors are there. Few 3-dimensional vectors are present, but not all 3-dimensional vectors are present. Few 3-dimensional vectors are present. Here also, few 3-dimensional vectors are present. Few 3-dimensional vectors are present. Not all. Few 3-dimensional vectors are there, but not all. But here, in this case, all the 3-dimensional vectors are present. All possible 3-dimensional vectors. So here I will write down all 3-dimensional vectors are present. All 3-dimensional vectors are present. All 3-dimensional vectors are present. Few but not all. Here, not a set of all dimensional, few 3-dimensional are present. Not a set of all possible 3-dimensional, few 3 dimensions are present. So here what I am writing down, a vector space of all possible n-dimensional vector, that is known as R3. So this will surely have n independent vectors. Why R3 Rn? So this will surely have n independent vectors. N independent vectors which will end up creating ND span. Okay, and if vector space of a few n-dimensional vectors we are having, what I will write down, a vector space of a few n-dimensional vectors, a vector space of few n-dimensional vectors. Okay, few, and here all. So let's write down all in a better manner. All. Okay, and here we have written few. So here it was all, here it is few. So it will be written as r to the power n only, but there will be some condition. Some condition will be known. So what you will end up getting? You will end up getting k independent vectors, and you will create a kd span. And one thing I am sure that k will be surely less than n. Is that clear to you or not? K will be surely less than n. Why is that so? This was a 3-dimensional set of vector, but we end up creating 1D span because we are having only one independent vector only. How many independent vectors we are having? Only one independent vector. Only one independent vector we are having. Only one independent vector we are having. So this was a set of 3-dimensional vectors, but one independent vector we are having. This was a set of 3-dimensional vectors, but we are having only 2 independent vectors. We are having only 2 independent vectors. And this was a set of all possible 3-dimensional vector, all possible 3-dimensional vector. So that's why we are having 3 independent vectors. I think everything is crystal clear, absolutely crystal clear. Say yes or no. This particular slide is the conclusion of everything in last 2 hours, whatever that we have studied, and that is absolutely clear to you. Say yes or no. Let's go to the next one. A, B, C, D belongs to R4. Condition is given A plus B plus C equals to 0, D equals to 3A. Span of V you need to find out. I will not do it. Let me know the answer on your own. If you are not able to tell the answer, then I am wasting the time here. Okay, I am wasting the time. I am not a good teacher. You can leave this video. But if you are understanding, then I need the appreciation. Okay, this time I need the appreciation. I want comments from your end that sir, we are currently at the 2 hours of this video, and sir, absolutely brilliant. Okay, those who are studying it for the second time, those who have already studied this topic from somewhere else, then they would be able to realize that what kind of depth has been given. Okay, if you are studying it for the first time, then you might feel that okay, this is how this topic is taught. But you try watching it from somewhere else, you would realize. Okay, please don't mind it. It's just that I have put a lot of effort to make this topic easy. Otherwise, this is very mathematical. This notation, that notation, and completely it will be messed up. But yeah, since this is the time of AI, no, right? People are focusing on AI, right? Linear algebra is coming on a good level. It's not that they will give you a matrix A, find out the eigenvector, find out the eigenvalue, find out the rank. They are framing good level of problem where you would require to use your mind, because this is the era of AI, and era of AI would start from linear algebra, and from this kind of linear algebra. We started with right basic, that how a 11th class guy would understand matrix and determinant, and how an engineer would understand matrix and determinant. To that particular point I will teach you. So when you put up an effort, sometimes these kind of things may come up. So please don't mind. I am not trying to be an arrogant teacher here. Okay, I never believe in these kind of things. It's just that some effort I have put up, so that's why I want the appreciation from your end. If students are appreciating, that will make me very happy. One comment would surely make me happy. So you can comment down. Okay, yeah. So next thing, a plus b plus c equals to 0, d equals to 3. So what will be the value of c? Here c is depending on d and a. Oh sorry, b and a. C is depending on b and a, and d is depending on a. So how many independent variables you are having? Two independent variables we are having and two dependent variables. Basically, if I frame a vector only, if I write down vector a, what that vector would be? If I take a as independent, what I am saying, only two conditions are given. No, let's just say I am taking a as 1. So what will be the value of d? For sure, sir, it will be 3. Now what is the condition you are having? A plus b plus c equals to 0. And next condition is 3a equals to d. So you can write down 3a minus d equals to 0. So are they independent of each other? Are these conditions independent of each other? Yes, sir. How many equations are there? Two equations are there. Two equation, 4 variable. That means two free variable would be there. Two free variable would be there. So how many two free variables? Let's just say b is a free variable. So if I say that b is 2, if I say b is 2, then can I take any random c? No. C will depend on b plus a. So c has to be minus 3. There you go. Understandable? So a is free. If I am saying that a is a free variable, b is a free variable, then c will be dependent and d will also be dependent. D will also be dependent. Now if someone says that a is free and c is also free, so if a is free and c is also free, then b will be dependent, right? If you say I am taking another vector, I am making, I am saying that a is 2 and c is 4. So if a is 2 and c is 4, then a plus b plus c has to be equals to 0. That means addition of all of them has to be equals to 0. So b has to be minus 6, right? And what will be d? D will be 3 times, so it will be 6. So if a is free and c is free, then b will be dependent and d is surely dependent, right? So what do you understand from here? That means there are two free variables and two dependent variables are there. That means there are two independent variables. Two independent variables. So it felt like that there are 4 dimension of a vector, but eventually there are only 2 dimension vector. Eventually there are only 2 dimension vector. So what will be the span? Span will be 2D only. Span will be 2D. That means how many independent vectors you will have? You will have 2 independent vectors. 2 independent vectors. If I was having a 4-dimensional vector, if I was having 4-dimensional vector space, I felt that I can have 4 independent vectors. If I am having 4-dimensional vector space, then I thought that I will have 4 independent vectors, but there are 2 conditions given. If 2 conditions are given, what does that mean? That means they have killed 2 variables. So effectively I am ending up getting only 2 independent vectors. 2 independent vectors. Okay, so it is a 4-dimensional vector space which is giving you 2 independent vectors, that is giving you 2D span. Understandable? Now we need to understand the meaning of linear span. You already know the meaning of linear span. Nothing new is there. Okay, we will understand the meaning of linear span. 3 kind of statements are written. Any kind of statement could be written in the examination hall. You will understand the meaning of linear span and then we will solve the problems. So now everything is related with problems only. Problem, questions we are solving, right? Next question we are solving, question we are solving, then some language is written, then question we are solving, then another question we are solving, another question we are solving, another question we are solving, then another question. So everything is related with problem only. Okay, now complete problem solving is there. So I will take a break, then I will come back and we will understand the meaning of linear span. Linear span is simply something that you already know. If I say vector C is depending on the linear span of vector A and B, vector C is depending on the linear span of vector A and B, then this is the meaning. That using the linear combination of A and B, you can create vector C. Using the linear combination of A and B, you can create vector C. Or what you will say, or you will say that what you will say that vector C belongs to the linear span of vector A and B, or what you will say, this is the first statement, what you will say, C is spanned by vector A and B, or what you will say, vector A and B, this is just active voice, passive voice, okay, this is the passive voice, this is the active voice, that vector C is spanned by vector A and B, or you can say A and B spans vector C. So active voice, passive voice is there, okay, active voice and passive voice. So did you understand the meaning of linear span? If I am saying that vector C is if vector C is belonging to the linear span of A and B, that means vector C is spanned by vector A and B, or you can say vector A and B is spanning vector C. Is that clear to you or not? So you need to check if 2 and 4 belongs to the linear span of 1 and 3, sorry 1, 3, basically here comma would not come, no? Okay, when you are writing down the vector, y comma would come. Let's just say 2 I cap plus 3 j cap, right? So if I write down the vector, I will write down 2, 3. This is a matrix, no? Y comma will not come, okay? In matrix, comma will not come, no? Right? So this is just a habit, comma will not come. Yes. So what I need to check, that if vector C is belonging to the linear span of vector A and B or not. So I mean to say is that linear combination of 1, 3 and minus 1, 2 gives you 2, 4 or not. This is what I want to check. That means alpha, here this will become alpha. Basically what this is I cap plus 3 j cap. What is this vector? This vector is nothing but I cap plus 3 j cap, right? And what is this vector? This vector is nothing but minus I cap plus 2 j cap. And what is this vector? This vector is 2 I cap plus 4 j cap. So alpha will be multiplied with I cap. So alpha I cap, it will become plus, basically if alpha goes inside, you know the addition, no? Alpha goes inside, this will become alpha, this will become 3 alpha, plus this will become minus beta, this will become 2 beta, that is equals to 2, 4. I am doing the matrix addition. So element wise element addition I will give. So alpha added with minus beta and 3 alpha added with 2 beta. So from here alpha minus beta is coming out to be 2, 3 alpha plus 2 beta is coming out to be 4. Right? This is the scenario we are getting. Now, do I need to find out the value of alpha beta? No. I only need to check if there exists any alpha beta which satisfies this condition. What I need to check, if there exists any alpha and beta which satisfy this linear system. What does that mean? What does that mean? That means I need to check whether it is having a consistent solution or not. Consistent solutions or not. I don't care whether it is having unique solution or it is having infinite number of solutions. I don't care. Or it is having infinite number of solutions. I don't care. Or infinite number of solutions. I don't care. I just need to check whether they are consistent or not. So if they are consistent or not, how will I check? I will make the matrix A augmented B 1, minus 1, 2, 3, 2 and 4. So this is 1, minus 1, 2, thrice of this you need to subtract. So this will become 5 and this will become minus 2. Surely you can see that rank of A is coming out to be rank of A augmented B. Although it will have a unique solution, but that's not a matter of concern. That means yes, surely alpha beta exist. If they exist, that means yes, this belongs to the linear span of this vector belongs to the linear span of vector 1, 3, minus 1, 2. So what will be the value of alpha beta? That also you can find out. Directly I can see from here is that beta will come out to be minus 2 by 5. Okay, and this will be minus 2 by 5 and then 2 minus 2 by 5. What it will become? So this is 0.4, so this will become 1.6. So this is minus 0.4, this is minus 0.4, and alpha will become 1.6. So these are the values of alpha and beta, right? Say yes or no. Yes. So yes, there exists some value of alpha and beta which for which vector 2, 4 belongs to the linear span of vector 1, 3 and minus 1, 2. Or you can say 1, 3, or you can say 2, 4 is being spanned by 1, 3 and minus 1, 2. Or you can say 1, 3 and 1, 2 spans 2, 4. Spans means, what is the meaning? That means whatever the span that they are going to create, 1, 3 and minus 1, 2, whatever the span they are going to create, in that span 2, 4 will be present. Again, let me add another page and let me tell what this is saying. That you are having vectors 1, 3 and minus 1, 2, 1, 3 and minus 1, 2. So using these two vectors, can anyone let me know what will be the span I will be able to create? 1, 3 minus 1, 2. Sir, are they independent of each other? 1, 3 minus 1, 2. Are they independent of each other? Yes, sir. Here what will be the rank you will be getting? Rank I will be getting is 2. So they are two independent vectors. Two independent vectors. So if they are two independent vectors, then what is the span they are going to create? They are going to create a 2D span. Now in this 2D span, I will have any two-dimensional vector. In this 2D span, I will have any two-dimensional vector. So any kind of two-dimensional vector I will be able to make by 1, 3 and minus 1, 2. Basically, I will be able to make 0, 0 as well. I will be able to make 2, 4 as well. I will be able to make 1, 3 as well, or whatever that was given. 2, 4. I will be able to create 2, 4 as well. What does that mean? Using 1, 3 and minus 1, 2, I will be able to create all possible. What does that mean? I will be able to create all possible two-dimensional vector. Two-dimensional set of all possible two-dimensional vectors. And what it is known as? This is known as R2. So what I can say in language, that 1, 3 and minus 1, 2 spans R2. There you go. Did you understand this point or not? In the examination, if this kind of question is coming, I will not solve by this method. If you want to solve by this method, that also is fine. I will see that, okay, these two vectors, what these two vectors are spanning. So 1, 3 minus 1, 2, sir, they are independent of each other. That means they will be able to create a 2D span. In 2D span, whatever the two-dimensional vector is coming, everything they will be able to span. That means using these two guys, I can make any two-dimension vector. Using these two guys, I can make any two-dimension vector. So sir, all possible two-dimensional vector I will be able to create, which is known as R2 only. So that means 1, 3 and minus 1, 2 is spanning R2. Is that clear to you or not? Is it clear or not? So this you can write down as note. Okay, very, very good points we are going to give. If everything is crystal clear to you, then you will be able to solve the problem by 3, 4 methods. Okay. This question, check if 1, 3 and minus 1, 2 spans R2 or not. 1, 3 minus 1, 2. Are they two independent vectors? You can check it on your own. Yes, sir. Two independent vectors. Two independent vectors. What is their span? Span is 2D. And what is the span of this? That is also 2D. The span of this is 2D. Span of this is also 2D. Yes. What is the answer? Yes. 1, 3 minus 1, 2 span R2. Basically, using 1, 3 minus 1, 2. Again, I hope I am not using the comma again and again here. Oh, comma again and again I am using. Here I am not using comma. Yes. So what do you understand? Using 1, 3 and minus 1, 2, I can create all possible two-dimensional vector. But using 1, 3 and 2, 6, Can you create it? No. 1, 3 and 2, 6. Let's call it vector B and let's call it vector A. You can directly see that, sir, B is nothing but twice of A. That means I am having only one independent vector. Only one independent vector. And if I am having only one independent vector, what does that mean? Only one independent vector I am having. What does that mean? That means my span will be 1D span. And what is the span of R2? R2 means all possible two-dimensional vector. That means two independent vector I will have. So span of R2 is 2D. So here span is 2, here span is 1. What will be the answer? Answer will be no. Okay, what will be the answer? Answer will be no. That means 1, 3 and 2, 6 does not span R2. What you will say? 1, 3 and 2, 6 does not span R2. There you go. Is that clear to you? Which of the following set of vectors spans R2? For spanning R2, what do you need? You need two independent vectors. Two independent. Basically, what is the span of R2? What is the span of R2? First, you will write down what is the span of R2. What is the span of R2? So, span of R2 is 2D span it is having. If it is having 2D span, what does that mean? It needs two independent vectors. Two independent vectors. And R2 means it will be two-dimensional, right? So what is the conclusion? You need two-dimensional, two independent vectors. This is the requirement. Two-dimensional, two independent vectors I need. Is it two-dimensional? All the options are two-dimensional. Yes, two-dimensional, two-dimensional, two-dimensional. Here you are having two vectors, here you are having two vectors, here you are having three vectors, here you are having four vectors. So yes, two-dimensional vector I need. So first condition is satisfied. Now I need two independent vectors. So 1, 2 minus 1, 2. Are they independent of each other? Calculate the rank. 1, 2 minus 1, 2. So 1, 2 minus 1, 2. Calculate the rank. From this will be subtracted. This is 1 minus 1. So this will be subtracted. So what is the rank? Rank is 2. Yes, both are independent of each other. Both are independent of each other. That means yes, two independent vectors we are having. This is the requirement. Done. Are they independent of each other? No. Calculate the rank. 1, 2, 0.51. What is the determinant we are getting? We are getting the determinant to be 0. That means what is the rank? Rank is 1 only. If rank is 1, that means only one independent vector we are having. Here, how many independent vectors we are having? Can you create 3 independent vectors? Using two-dimensional vector, I can create maximum 2 independent vectors. But how many independent vectors I am having? I can sense one thing. Yes, sir. 1, 2, 0.51 and 3 minus 1. This was the condition. So if I calculate the rank, what I will do? For calculating the rank, I can see one thing. Yes, sir. 1.53. Then I will do the twice of this and then subtract twice of this and subtract it from here, twice of this subtracted from here, twice of this subtracted from here. So what is the rank I am getting? Rank I am getting is 2. That means yes, there are two independent vectors and you can directly see they are independent of each other. No, someone would say that, sir, they are dependent. Yes, they are dependent, but what do I need? I need two independent vectors. So I need this is independent and this is also independent. Both are independent of each other. That means yes, it is done. What about these guys? So this guy is depending on this one. This guy is depending on this one as well. And this guy is depending on this one as well. Basically, this is simply the 2 times. This is simply the 4 times. And this is simply 8 times. And if you calculate the rank as well, you can calculate the rank 2, 4, 8, 16, 3, 6, 12, 24. What you will do? What transformation you can apply? The transformation that you can apply is that in R2 what you replace? Do the twice of R2 and subtract thrice of R1. Thrice of R1 6 and 2. So you will get to know that this will be a non-zero row and this will be a all zero row. So rank will come out to be 1, which is pretty obvious because only one independent vector is there. So this will not span. So what is the rank? Rank is coming out to be 1 only. So you need two independent vectors. Here we are getting only one independent vector. Here also we are getting one independent vector. What we are getting? One independent vector. Here also we are getting one independent vectors. That means not satisfied, not satisfied. Yes, here we are getting two independent vectors, and here also we are getting two independent vectors. That means A and C will span. The rest of two of the options will not span. Let me know the answer. Yeah. So language, one language is there. What they can say? 1, 2 and minus 1, 2 is spanning R2, no? So the language they can use is 1, 2 and minus 1, 2 are basis of a vector space R2. 1, 2 and minus 1, 2 forms the basis of vector space R2. Is that understandable to you? Now 1, 0 and 0, 1 will also, R3 yo, R2. Now 1, 0 and 0, 1, are they independent of each other? Yes, sir. They are independent of each other. That means we are having two dimensional, two independent vectors which will span R2. So what language you can say? 1, 0 and 0, 1 forms the basis of R2. Next one, 1, 2, 2, 4. Are they independent of each other? No, they are dependent. Will they span R2? Does not span R2. So what you will say? 1, 2 and 2, 4 does not form the basis of vector space R2. What about this one? 1, 2 and 2, 4. 1, 2 and 2, 4. This is how I write down. 1, 2 and 2, 4. What about this one? 2, 3, 4, 4. Are they independent of each other? Yes, sir. They are independent of each other. That means they form the basis of R2. Yes, they will form the basis of R2 for sure, because they are independent of each other. That means yes, they will be able to span R2. So forms the basis of. What does that mean? Spans. That's it. Forms the basis of. Spans. So find out the basis of R2. 1, 2 minus 1, 2, 1, 0, 0, 1, 1, 2, 2, 3, 4, 4, or 1, 2 minus 1, 2, or 1, 2, 0 0.5, 1, 3, 3 minus 1. But this I will not call as basis, because this is irrelevant, no? This is irrelevant, no? 0.51 is irrelevant because it is depending on this one. So you can erase 0.5 and 1. What you will say? 1, 2 and 3 minus 1 are framing the basis of R2. So just the language. Someone would say basis of. So you should be able to understand that this is the basis. That using 1, 2 and minus 1, 2, you can frame any two-dimensional vector. Is that clear to you or not? Okay. Solve this question. Have patience. Think about it and let me know the answer. Okay. Have some patience. Think about it. What is the meaning of this? R3 y 2x. First, what is the meaning of R3? R3 simply means that it will be a three-dimensional vector. Surely it will be a three-dimensional vector. This is the first condition. Three-dimensional vector. But how many independent vectors would be there? Three-dimensional vectors, but how many independent vectors would be there? Sir, I thought that three-dimensional vector, all possible three-dimensional vector would have been there. Then I would get three independent vector. But because of this condition, I will get only two independent vectors. So what is my least requirement? That I need two independent vectors. I need three-dimensional two independent vectors. This is my requirement. Three-dimensional two independent vectors, which is satisfying this condition where y is equals to 2x. So what is the requirement? Did you understand? What is the requirement? The requirement is three-dimensional at least two independent vectors. Two independent vectors satisfying y equals to 2x. This is the requirement that you are having. Do you agree to this point or not? And why I have written at least? If I am getting three independent vectors as well, then also it is fine, no? Using three-dimensional set of vectors, if I am getting three independent vectors, that at least two independent vectors you are already having. No, you need only two independent vectors. You need only two independent vectors. If you are getting 3 independent vectors as well, then also it is fine, but it will not even be possible. Can you get more than 2 independent vectors which is satisfying this condition y equals to 2x? Again, listen to my statement very carefully. What I am asking, can you get 3 independent vectors of 3 dimension which is satisfying y equals to 2x condition? Again, can you get more than 2 independent vectors? Can you get more than 2 independent vectors which are of 3 dimension satisfying the condition y equals to 2x? Write down this question and give me the answer. Answer is no. Why it is no? You know the reason. I am not going to explain again. Can you get more than 2 independent vectors of 3 dimension which will satisfy the condition y equals to 2x? No, you will not be able to get. This is something that we have already studied, no? Right? Because R3 y equals to 2x will create a 2D span only. That means I can have only maximum 2 independent vectors. So let's check the option. The first condition is that y equals to 2x should be satisfied. Y equals to 2x satisfied. Y equals to 2x satisfied. Yes. Right? And both are independent of each other. Yes, both are independent. You can find out the rank on your own. Both are independent of each other. Yes, we are having 2 independent vectors. Right? This is not even satisfying the condition. 3 is twice of. Basically, are they independent? One is, you can find out the rank, you will get to know that yes, they are independent. So we are having 2 independent vectors. 2 independent vectors. But is it enough? No. Here what you see, y is not equals to 2x. So 2 independent vectors, but not satisfying the condition. Not satisfying the condition. That means not selected. Let me know here. Satisfying the condition? Yes. Satisfying the condition? Yes. Satisfying the condition? Yes. Are they independent of each other? One is twice and this is thrice, twice, thrice, 6 times, 6 times, 6 times. No, they are not independent. You can find out the rank on your own. You can directly see, no, this is twice of this and this is 6 times. So how many independent vector I am having? Only one independent vector I am having. One independent vector. So only one independent vector we are having, not selected. How many independent vectors you are having here? Satisfying the condition? Yes, sir. Satisfying the condition? Yes, sir. Satisfying the condition? Yes, sir. This is twice, and this is twice. So they are depending on each other actually. If you do the 2 times of this, they are depending on each other. But if you do the 3 times of this, then you are not going to get 7 here. 3 times of this will be 12. So here 12 is not written, here 7 is written. That means they are independent of each other. They are independent of each other. So I am getting 2 independent vectors. 2 independent vectors. Both are satisfying the condition y equals to 2x, y equals to 2x. This will also be accepted. Let me know the answer of this one. Someone would say that, sir, this is satisfying the condition. This is also satisfying the condition, but this is not satisfying the condition. No, this will be wrong. Okay. What I need? I need 2 independent vectors of 3 dimension which is satisfying the condition y equals to 2x. How many independent vectors you need? 2. 2 independent vectors which is satisfying this condition. This vector is not satisfying this condition. So what? I don't care. I need 2 independent vectors. Are they independent of each other? Are they independent of each other? Independent? Say yes or no. Yes, they are independent of each other. How you can find out? You can find out the rank. You will get to know. Yes, they are independent of each other. Are they satisfying the condition? Yes. So 2 independent vectors which are of 3 dimension satisfying the condition y equals to 2x. Done. Although this is not satisfying the condition, so you can ignore it. No. Basically the point is that my R3 which is having the condition of y equals to 2x should be spanned by linear combination of alpha, linear combination of vector A, vector B and vector C. This is the condition, no? So here I am writing down 2, 4, 7. Here I am writing down 3, 5, 4 and here I am writing down 4, 8, minus 3. I got to know one thing. What I got to know? That these two are enough. This is not useful for me. These two guys are enough. These two guys are alone enough. This is not useful for me. So what I will do? I will keep the beta to be 0. There you go. Right? but that's not correct. Okay, that's not correct. Why is that so? Just now it clicked to me. It's a good example. E will still not be correct. As of now, it feels like that, sir. Yes, you put beta equals to 0, then alpha 247, gamma 48 minus 3, that will be able to satisfy. When we write down this condition, which condition? Which condition I am talking about? This condition we write down. What else we write down? That alpha and beta simultaneously cannot be 0. Say yes or no. So sir, whatever the explanation that you have given, based on your explanation, what I feel like that I will not even need this vector, right? I will not even need this vector, so I will put the value of beta equals to 0. I will always keep it 0 only. Let's just say someone wants me to frame R3 y equals to 2x. This is the condition I need to keep, no? So someone wants me to frame 1, 2 and let's just keep it 3.5. So if someone wants me to frame this particular thing, I want this vector. What do I want? I want 1, 2, 3.5. So sir, what I will do? Half of this alpha value I will keep half. So 2, 4, 7. This will give me 1, 2, 3.5. This 0, 3, 5, 4. And then this also 0, 4, 8 minus 3. Right? So this is what I will do, sir. So alpha value I have kept 1 by 2. Beta value is 0. Gamma value is 0. Yes, I am able to create this. Now let me know one thing. Let me know one thing. Does this belong to R3 y equals to 2x? Yes sir. X is 0, so y also has to be 0, z also has to be 0. So this belongs to R3 y equals to 2x, right? But then here as well you will say the same thing, that multiply with 0, 0. If you need 0, 0, then you will have to multiply with 0, 0. Simultaneously they have to be 0, right? Y equals to 2x. If I need 0, 0, simultaneously they have to be 0, 0 only, no? So alpha, beta, gamma can simultaneously be 0. Okay, when we talk about the linear span, this is not a necessary condition. This is not necessary. This condition is not necessary. Really sorry for this blunder from my end. Okay, this is not a necessary condition. Why it is not a necessary condition? Why it is not a necessary condition? Because sir, if it is a necessary condition, then if I need for spanning R2, what do I need? That I need 0, 0 as well. So if I need 0, 0, then this I will have to multiply with 0, and this also I will have to multiply with 0. There is no other way. Are you able to understand this point? Are you able to understand this point or not? I will have to multiply with them 0, 0, no? Then only I can get 0, 0 vector. There is no other way, right? I will have to multiply this with 0 as well, this with 0 as well, and this with 0 as well. Then only I will get 0, 0. So my alpha, beta, gamma will be 0. Alpha and beta will be 0, right? So needlessly here I wrote down another condition, that alpha, beta simultaneously has to be 0. No, there is nothing like that. This condition is not even there. Simultaneously they can be 0. Okay, alpha, beta simultaneously can be 0. Simultaneously can be 0. Why is that so? Because if I want a 0, 0 vector, if I am saying that this is spanning R2, this is spanning R2, so in R2 0, 0 vector will also be there, no? So if I want 0, 0 vector, then how I will be able to get it? For that I will have to multiply this with 0 as well and this with 0 as well. Without multiplying both of them to 0, I will not be able to get a 0, 0. So if I want to get 0, 0, I will have to multiply with 0, 0. Right? So yes, they have to be simultaneously 0, 0. So there is no doubt that both of them could be simultaneously 0, 0. So needlessly I wrote down another condition. I just thought too much. Okay, I just thought too much. That's why this doubt came to me when I was teaching only. So I just thought too much and I created a doubt, then I solved it, and then again I created a doubt, then again I solved it. So what is the conclusion? That yes, it will span. Yes, it will span. You can put this as 0 as well, you can put this as 0 as well, and you can put this as 0 as well. I hope you are clear. Okay, I hope you are not getting confused with this particular thing, that yes, simultaneously they can be 0 as well. If I need 0, 0, 0, if I need 0, 0, 0, yes, they will simultaneously 0. They will be simultaneously 0, which is fine for me. Yes, you can take simultaneously, take them 0, 0, 0. Understandable? The only requirement is that I need two independent vectors which are of 3 dimensions satisfying the condition y equals to 2x. So although this is not satisfying the condition y equals to 2x, so I will always keep it 0 only, right? I will always keep it 0. That means yes, these 3 vectors are spanning my R3 which is having the condition of y equals to 2x. Understandable? Okay. Now another option I am adding, F option I am adding, that option is 2, 4, one 3. So this will not span, no, or anything you write down, 4, 7 you write down, whatever you want to write down. This will not span. This will not span R3. Why is that so? Because you would require 3-dimensional vector, and here you are having 2-dimensional vector only. So you don't even need to check dependence or independence. You can directly say that they are 2-dimensional vector. So 2-dimensional vector will not be able to span. I need 3-dimensional vector. Although this kind of example will not even be given in the examination. They will, if they are asking about R3, they will give all 3-dimensional vector only. Okay, they will not give 2-dimensional vector, but still, if someone is having the doubts that can I span it using 2-dimensional vector, the third dimension is not even there. So how you will be able to span R3? For R3 you need 3 dimension, no? Right? So this will not be the possible option. Solve this question on your own. A, B, C, D, 4 options are there. Yes. Solve this question on your own. Let me take a break because it's been roughly around 100 minutes. I am speaking continuously. I will drink some water and then I will come back. We will solve 1, 2, 3, 4, 5. Yes, 5 question more. So 5 more questions we will solve. Okay. You can try on your own. This you can try. This also you can try. Very simple questions. This also you can try. Although this feels like that, sir, what this is given. But if you just read the statement, you will be able to solve it. Okay, read the statement, you will be able to solve it. Understandable? So yeah, let me take a break and then I will come back. And I am sorry for this particular blunder. I just thought too much. Okay, I started thinking too much that alpha, beta, gamma will be simultaneously 0. Then, but that was the condition of linear dependence, not the linear span. Right? Are you able to understand what I am saying? That sir, in one of the lecture you wrote down, no, if C is linearly depending on A and B, then sir, alpha and beta, lambda 1 and lambda 2 cannot be simultaneously 0. So somewhere you wrote down. That was the condition of dependence of vector, not the span. Right? If this guy wants to span them, that means 0, 0 vector also has to come. And if you want 0, 0, 0 vector, then there is no other way than getting them, than writing down them as 0, 0 only. Understandable? Okay. Yes. Yeah. So let's solve this question. Yeah. Welcome back. So did you solve this question? X, Y, Z belonging to R3, Y equals to 2x, X, Y, Z equals to X plus Y plus Z equals to 0. So there are conditions on 2 variables. This kind of question we have already seen, right? Y equals to 2x. Along with that, X plus Y plus Z equals to 0. So what is the meaning of R3? That we require 3-dimensional vector. 3-dimensional vector we require. Right? 3-dimensional vector we would require. And how many independent vectors we would require? Sir, R3, 3 independent vectors we would require, but there is a condition, we are killing one variable y. Along with that, from here what do I see? That sir, Z is given as nothing but minus x minus y. And y is nothing but 2x, so Z is nothing but minus 3x. So Z is also depending on x, y is also depending on x. So effectively there is only one dimension. That means how much independent variables I will require? Sorry, how much independent vectors I would require? Only one. So what is my requirement? My requirement would be, what will be my requirement? That I would require 3-dimensional one independent vector. 3-dimensional one independent vector which is satisfying the condition y equals to 2x and x plus y plus z equals to 0. So is it a 3-dimensional vector? I want only one vector, no? I want only one independent vector. Is it a 3-dimensional vector? Yes, sir. Is it satisfying the condition y equals to 2x? Y equals to 2x? Yes, sir. X plus y plus z equals to 0? Yes. Done. So it will surely span. Here I am having 3 vectors, right? Here how many vectors I am having? 3 vectors I am having. But I need only one independent vector. So it is independent? Yes. Here you will say that, sir, this vector, let us say this is vector v. So vector b is depending on vector a. Along with that, vector c is also depending on vector a. But I don't care about these two guys. I only need one independent vector. I only need one independent vector with the condition that y should be equal to 2x. Yes, it is that twice x plus y plus z equals to 0, x plus y plus z equals to 0, satisfied. I don't even need to look at these guys. They are satisfying the condition or not, I don't care. I need only one independent vector which is satisfying this particular condition. So 3-dimensional vector, one independent vector I need. Y equals to 2x, yes. X plus y plus z equals to 0, yes. So yes. Now someone would say that, sir, this is not satisfying the condition. Here, this is not satisfying the condition that x plus y plus z equals to 0. This is not satisfying this condition. So what? So what? This explanation I gave, no, that I will multiply it with 0, right? So I don't even need to use this vector. At the end of the day, I need one independent vector which is satisfying these conditions. 3-dimensional, one independent vector which is satisfying these two conditions. So 3-dimensional, one independent vector which is satisfying these two conditions. So this is also correct, this is also correct, this is also correct. Now here none of the vector is satisfying this condition, no? Like here y is equals to 2x, but x plus y plus z equals to 0. No, x plus y plus z equals to 0 is not being satisfied anywhere. It is not being satisfied anywhere. So none of the vector is satisfying this condition, that means it is gone. Although yes, I am getting one independent vector. Yes, one independent vector I am getting. One independent vector I am getting. But we need to satisfy this condition as well, no? Y equals to 2x is also being satisfied, but x plus y plus z equals to 0 is not being satisfied. That means this option is gone. Very simple thing. Will you be able to solve these kind of problems? If you see the solution, then how they do is that they will pick up option A, then B and C and D, then they will solve it separately, and then they will check whether it is being whether these vectors are spanning it or not. So it will take so much of time. But if your concepts are clear, that what is the meaning of R3? R3 means 3-dimensional, 3 independent vectors. But sir, 2 condition I have put. That means 2 variables I have killed. So only one effective variable is there. That means 3-dimensional, 1 independent vector. So 3-dimensional, 1 independent vector, will I be able to check? Absolutely. Within 1 minute I will be able to solve it. Otherwise it will take 7 to 8 minutes. Understandable? So I hope your concepts are clear. Answer this question to me. 99 people out of 100 people will leave this question. If this kind of question is coming in the examination hall, 99 students out of 100 will leave this kind of problems. But you will be able to solve in a very easy manner. What they are saying? A set of n linearly independent vectors in Rn spans Rn. What is the meaning of this? N linearly independent vectors in Rn. Vectors in Rn. What is the meaning of vectors in Rn? That in the vector space Rn, we are having n linearly independent vectors. Basically, to span Rn, what will be the span of Rn? It will be n-dimensional span. So to span Rn, how many linearly independent vectors you will need? You would need n linearly independent vectors. Linearly independent vectors. So yes, a set of n linearly independent vectors in Rn will span R to the power n. Not R to the power n, this is known as Rn. Okay, not R to the power n. We call it R2, not R to the power 2. Okay. So this was A. What was B? Any set containing fewer than n linearly independent vectors in Rn cannot span Rn. Yes. For this particular, the same explanation. R to the power n. If I need to span R2, not R to the power n. If I need to span Rn, then that means I need n linearly independent vectors. N linearly independent vectors. But if we are having fewer than n linearly independent vectors, then we will not be able to span it. Right? If it is R to the power 3, then I would require 3 linearly independent vectors. But if I am not having 3 linearly independent vectors, if I am having only 2 linearly independent vectors, then I will not be able to span R3. Understandable? Next, any set containing more than n vectors in R to the power n is necessarily linearly dependent. What does that mean? If you are not able to, if you are not able to understand with Rn, let's take the example of R3. Any set containing more than 3 vectors in R to the power 3 will be linearly dependent. What is the meaning of R to the power 3? R to the power 3, not R to the power 3. What is the meaning of R3? 3-dimensional vectors. 3-dimensional vectors whose coefficients are real. That means I am creating a set where I am having 1, 2, 3, minus 1, 2, 4, 2, minus 1, 3, and 2, 1, 4, and so on. 2, 1, 4, yes, and so on. So in this particular set, maximum number of linearly independent vectors What will be the maximum number of linearly independent vectors? I told you, if I am having n dimensional vector, if I am having a set of n dimensional vector, then I can have maximum n linearly independent vectors. I know that this and this is linearly independent, but surely this guy will be depending on these three people, right? This we have proved as well. Why is that so? Because let's just make a matrix. I will get to know that here only 3 rows will be there, no matter how many columns are there. The maximum rank that I can get is 3. What does that mean? That means maximum I can get 3 linearly independent vectors. So what this line is saying, any set containing more than n vectors. Here how many vectors we are containing? 4 vectors we are containing. Any set containing more than n vectors means here we are containing 4 vectors. So fourth vector will surely be depending on previous 3 vectors. Yes. Okay, so this also we have proven. So in a short manner, whatever the way, in whichever the way you want to write down, this also we have proven. It is just that whatever the things that we have proved, we are just writing on the statement of all those things, right? Nothing else. It is just a mathematical statement. A set containing more than n vectors in R to the power n. That means there is a n dimensional set of vector. Rn means n dimensional set of vectors. We are having more than n vectors. That means surely they will be linearly dependent. So they will create a set of linearly dependent vectors. So option C is also correct. Option D, a set of vectors in Rn spans Rn if and only if it contains n linearly independent vectors. Right? What is the meaning of if and only if? If and only if means the statement should go both of the side. A if and only if B. I told you. What is the meaning of this? If B, then A. If A, then B. So if and only if is written, then you need to consider there are two statements. So in this statement there are two statements. If a set of vector in R to the power n spans Rn, then it contains at least n linearly independent vector. Is that understandable to you? Right? If we are spanning R to the power 3, if we are spanning R to the power 3, what does that mean? We need 3 linearly independent vectors. Right? 3 linearly independent vectors. It is pretty obvious. To span R3, we need 3 linearly independent vectors. And secondly, if we are having 3 linearly independent vectors, that means surely it will span R3. Have we seen those examples? No. We were having, here this example we saw, we were having 2 linearly independent vectors, it was spanning R2. And to span R2, we need 2 linearly independent vectors. That is also correct. Right? These statements may feel like that, sir, what we are studying, but if you know the meaning of everything, then they are very straightforward to you. To span R3, we would need 3 linearly independent vectors. And if we are having 3 linearly independent vectors, then we will be able to span R3. That's it. Straightforward. That means statement goes both of the side. Statement D is also correct. These kind of questions will be considered not even tough, they will be considered very tough. Okay? But here we are sure with every single line. What is the meaning of every single line? Everything is crystal clear to us. Say yes or no. Let's see this question. Vector v1 is there, v2 is there, v3 is there. They are the vectors in R3. Okay, R3 means 3-dimensional vector having real coefficient. 3-dimensional vector having real coefficient. Right? Which of the following statements are true? Vector v1, v2, v3 forms a basis of R3 for all lambda not equals to 25. What does that mean? Forms the basis of, what is the meaning of this statement? v1, v2, vt form a basis of R3. What did I tell you? What is the meaning of this? Form a basis of spans. So what they are saying? v1, v2, v3 spans R3. For spanning R3, how many independent vectors you need? 3 independent vectors you need. 3 independent vectors I need. For spanning R3, how much vectors I need? 3 independent vectors I need. So are they 3 independent vectors? That means they have to be independent of each other. That means they have to frame a set of independent vectors. That means v1 should be independent of v2 and v2 should be independent of v3. That means v1 and v3 should also be independent of each other. So all 3 are independent of each other. That means if all 3 are independent of each other and I make a matrix, if all 3 are independent of each other and I make a matrix, then what will happen? 2 minus 1, 3. 2 minus 1 3, 1 4 minus 2, 1 4 minus 2, lambda 5 1. So this is the matrix D I have made. If I want 3 linearly, how did I write down 2 minus 1 3? That means if I want 3 linearly independent vectors, what does that mean? What do I want? I want 3 linearly independent rows. Say yes or no? All these three should be linearly independent. What does that mean? That means I want rank of D to be 3. If I want rank of D to be 3, what does that mean? What is the meaning of rank of D should be 3? That means determinant of D should not be equal to 0. Say yes or no? If you want the rank to be 3, that means the some matrix of order 3 cross 3 should not be throwing the determinant equals to 0. That means this determinant should not be equals to 0. This is the demand. So can you find out the determinant? Yes, sir. 4, 10, this will become 14. Then minus 1 will become plus 1. Then this and this will be gone. 1 plus 2 lambda. And then plus 3. So 5 minus 4 lambda should not be equals to 0. So 14 lambda plus 2 lambda minus 12 lambda plus 16 should not be equals to 0. 16 by 4. अरे भाई क्या कैलकुलेशन कर रहा हूँ मैं ये. 14 lambda plus 2 lambda plus 1 plus 15 minus 12 lambda. 22 by 5 they are saying, no. Look, this kind of calculation I am having, and then people think that I can get AIR1. No, I cannot get AIR1. Okay, so 1 minus 1 plus 2 lambda 3, 5 minus 4 lambda. Okay, 15 minus 20 lambda, 15 minus 5, 15 minus 12 lambda. 2 minus 1 3, 1 4 minus 2, lambda 5 1, lambda 5 1. Okay, so 14 lambda, is that correct? 4 10, yes. Then 1 minus 2 lambda, yes. 3 5 minus 4 lambda, yes. 15 minus 12 lambda plus 1 plus 2 lambda, 10 lambda, 16. And क्या बात है यार, 16 4 lambda. 4 lambda should not be equals to minus 16. So lambda should not be equals to minus 16 by 4. Lambda should not be equals to minus 4. What this is saying? 22 by 5. क्या भाई ये? Wait a second. Okay, there is some calculation error here. I need to frame the options in a better manner, so I will frame the options in a better manner. Okay, just wait a second. So you would have surely seen my mistake, right? What mistake I was doing? There was no problem in the answer. There was some problem with my solution. What was the mistake I was doing? I have written lambda here in place of 2, and I checked it twice, and I was not able to understand that here I have written lambda. And I am pretty sure that this kind of things happens with a lot of students, right? I was a student, I used to do this kind of things. In the examination, what you can do? Let's just say the question would have come that let's just say it was a numerical answer type question. Find out the value of lambda such that v1, v2, v3 are independent of each other. Find out the value of lambda minus 4, you would have written, and losing 2 marks. Okay, just because of this particular thing, right? So what is this? I don't know. So these kind of errors, like, who can avoid? At the end of the day, these kind of errors would happen, and they would happen. No one can avoid them actually, right? This is a slight blunder. How these kind of errors can be eradicated? By more and more practice. As of now, I am an educator. No? As an educator, I don't need to do practice, right? Because I need to teach here. I don't need to show that this is how fast I do the calculation, less or minor mistake and all, right? So that's why I always say that it is not very easy to get a very good rank. Your concepts might be very good, but for getting the rank and all, you require the practice. That means you need to do the hard work. No matter how brilliant you are, at the end of the day, we need to do the hard work to get a good rank, right? So this kind of blunder I was doing. So this will become minus 10 lambda. So 10 lambda I am taking here. So 10 lambda should not be equals to 29 44. So lambda should not be equals to 22 by 5. So these kind of blunders happens with a lot of students as well. I'm not saying that this does not happen with students. At the end of the day, you need to practice more and more, and these kind of errors will be eradicated. Okay, and solve with more patience. I don't know why I wrote down lambda. There is no explanation. I don't have any explanation. I started from here. This was 2 only. I don't know why I wrote down lambda here. And when I again and again I'm checking the calculation, I am not able to understand that here in place of 2 lambda should have been written. That's why I always say that you should be solving the problems without looking at the solutions. Because if you look at the solution, then you will be able to understand that this was a mistake. But if you again and again look at it, then eventually you will be able to tell that yes, this kind of mistake I do. And if you understand that this kind of mistake you do, then in the examination you will not be doing these kind of mistakes. Okay, so just a lesson you are getting here, that this is how we will avoid these kind of mistakes, and your teacher is doing it live. Okay, your teacher is doing these kind of mistake live. So yeah, this is correct, that v1 v2 v3 will form the basis. That means v1 v2 v3 will span R3 for all lambda not equals to 25. The vectors are linearly dependent when lambda is 25. If they are linearly independent, then lambda should not be equal to 25. So if they are linearly dependent, then lambda should be equal to 22 by 5, right? The dimension of span of v1 v2 v3 is 3 for all values of lambda. No, for all values of lambda, but lambda should not be equal to 25, right? So what is the dimension here? The dimension here for these 3 vectors, the dimension will be 3D, or you can say span will be 3D, the dimension of the span. Okay, so you will get a 3D span for lambda not equals to 22 by 5, right? You will get a 3D span. That means you will have 3 linearly independent vectors for lambda not equals to 22 by 5. That means you will have 3D span for lambda not equals to 22 by 5. So this option will be wrong, right? Not for all values of lambda. For all values of lambda not equals to 22 by 5. Now, when lambda equals to 22 by 5, the vectors v1, v2, v3 spans a plane in R3. Spans a plane in R3. Plane in R3. What does that mean? Plane in R3. What does that mean? That means span is 2-dimensional. What is the meaning of plane? Do you remember? What is the meaning of plane? The meaning of plane is span is 2-dimensional. That means you are having 3-dimensional vector such that the span is 2D. What is the meaning of last line? The meaning of last line is 3-dimensional vectors. 3-dimensional vectors giving 2D span. What does that mean? You need 2 linearly independent vectors. So when lambda equals to 22 by 5, what you will get? The rank will be 2. Here in this example, if I put lambda equals to 22 by 5, you can calculate the rank. Rank of D is coming out to be 2. What does that mean? I am getting 2 linearly independent vectors. What does that mean? That means your span will be 2D, or you can call it a plane. Okay, so last option is also correct. If someone is reading the last option in a hurry, what he will say? Okay, the vector span R3, so it will not span R3, so he will not click on this option. But what they are saying, spanning a plane. If they have written spans at 2D plane, then you will be noticing it. But what is the meaning of plane? Plane means 2-dimension only, no? So span a plane in R3, that means yes, they are talking about the 2-dimension only. So what is the span? Span is 2D. Understandable? So this option is also correct. Next question. This is a gate PYQ only. I just modified it a bit. Okay, I just modified that gate PYQ. This was asked in gate examination only, but in a different manner. But I made it a bit more tougher. What that was asked, that was on easy level. When you solve the PYQs, you will be able to solve it. But I made it a bit tougher. Absolutely easy problem. Get the correct answer. Very easy question. There is a vector space that has been given, which is x1, x2, dot 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 xm minus x1 minus x2 minus x3 is not even written, dot 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 xm minus xm. This is the vector space you are having. That means this is one of the vector you are having. This is one of the vector you are having. One of the vector. So how many total vectors are there? Total 2m vectors are there. Total 2m vectors are there. And what they are saying, you need to find, D denote the dimension of the subspace spanned by this set. Sir, what do you mean by this subspace? So let's add a page. I need to explain what is a subspace. Okay, because I did not explain the meaning of subspace. Although without even knowing the meaning, you will be able to understand, but let's understand the meaning of subspace. So first let me know what is the meaning of set. Is this a set? S1 I am saying. Is this a set? Yes sir, it is a set. Now let me know, is this a set? Yes sir, this is also a set. But can you say S2 is a subset of S2 is a subset of S1? So if S2 independently is given, let's just say there is a question where they are talking about S2, which is 2, 3. So they can call it set. But if there is a question where they are talking about S1 as well, which is 1, 2, 3, and then they are talking about S2 as well, which is 2, 3. So they will call it this as set and this as subset. Is that clear to you? Because 2, 3 is the same element which is available in S1 itself. So this will be set, this will be subset. Similarly, if I say I have a vector V which is R3. Now, this is one question. I have a vector V which is R3. Another question you are having a vector space V which is R3, there x equals to y equals to z. Then another question you are having where you are having a vector space V1 which is R3 and V2 which is R3 with the condition x equals to y equals to z. So let me know, is it a set of vectors? Yes sir. So can I call it space? Can I call it vector space? Surely you can call it vector space. There is no doubt. Is it a set of vectors? Yes sir, this is also a set of vectors. So can I call it vector space? Yes, you can call it vector space. In this set, what all elements will come? Sir, any random element can come. 1, 2, minus 1, 1. Any random element can come, sir. 1, 1, 1 can come, also come. 2, 2, 2 can also come. And anything random can come up. Here what will come? Sir, here only 1, 1, 1 can come. And so on. Okay. Here only 1, 1, 1 can come. Or sir, 2, 2, 2 can come. Right? Anything random cannot come here. X has to be equals to y, has to be equals to z. But here any random value can come. Right? So now if I am considering both of the vectors together, what I will do? I will call this as vector space, but I will call this as vector subspace. So did you understand the meaning of vector subspace? Why is that so? Why I am calling subspace? Because whatever the elements that are coming here, the same elements will come here for sure. Whatever the elements that are coming in V2, the same elements will come in V1 for sure. V1 will have some extra element, but it will have all the elements which are present in V2. Understandable? So this will be vector space, this is a vector subspace. Understandable? What is the meaning of vector space? Set of vectors. Set of vectors is known as vector space. And what is the meaning of vector subspace? Vector subspace means whatever the element that are present in vector subspace, they will be surely present in vector space. Understandable? Very simple thing. So what they are saying, D denotes the dimension of the subspace spanned by this set. What does that mean? What does that mean? What is D? D is the span of V. That's it. Span of vector space V. Dimension of the subspace spanned by this set. Dimension. How do you say the space? Sorry, how do you say the span? Let's just say I say that the span of this vector set is 2D span. What does that mean? 2-dimension span I am having. 2-dimension span I am having. What is the language? 2-dimensional span. So what they are saying? Denotes the dimension of the subspace spanned by this set. Although this is not a big matter of concern, but I am just telling you that whatever the language is written in the full question, I will be able to tell the meaning of every single term. If that kind of confidence you are having in 60 questions out of 65 in your GATE examination, like when people solve the PYQs, what do they think? That sir, I need to get the solution. But I say one thing, if you are solving the PYQs and in a particular question, when you read that question, if you are not able to explain every single line, then there is no meaning of solving that problem. Not even in PYQs, whenever you solve any question, whatever the language is written, if you are not able to decode that language, no matter sir, this value I can get out, this value I can take, and then I will apply the formula, I will get the answer. That is, there is no meaning of solving these problems in this manner. What should be the actual way? Read the question. Are you able to decode everything that is given in that problem? Then only you will say that yes sir, I have solved this question. Otherwise, there is no meaning of that. Okay. This is how the question should be solved. I always used to say one thing, that if you are not able to frame the problem, no, that means you are not learning. Okay. let's just say I say, sir, I know engineering mathematics. So I should have the temperament that I will be able to frame the question. If I'm able to frame the question in a perfect language, that means I'm learning mathematics, otherwise I'm not. Sir, I'm able to solve the problems. Does that mean I learned mathematics? No. If I am able to frame the question, no, then I can say that yes, I have studied the subject. It might happen that as a student you cannot learn so much, right? Whatever that I'm teaching, you will learn only that part. You will not do the research on your own as a student. But once if someone like you would say that, sir, I want to be a teacher, then studying a subject being a teacher and studying a subject being a student, both are separate things. Okay, so let's not go in that direction. Yeah, so let's move to our topic only. What we were studying, we were solving this question. So you know the meaning of every single thing here. So what is D? D is simply the span of vector space V, right? So which of the following statements are true? If x1 x2 dot 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 or xm are mutually orthogonal, then the span will be m dimensional. Is that correct? The span will be m dimensional. Why is that so? One thing I am pretty sure, that value of D would be less than or equals to m. Why is that so? Sir, here there are total 2m vectors, right? Here there are total 2m vectors. Let's make a matrix D. So if I make the matrix D, how will I make it? X1 vector would be there, x2 vector would be there, x3 vector would be there, minus x1 vector would be there. Let's ignore x3. Let's directly take xm, and then sir, minus x1 would be there, minus x2 would be there, and then minus xm vector would be there. So this is how those vectors would be present, right? This is how those vectors would be present. One thing I am pretty sure, that minus x1 will be surely depending on x1, right? X2 will be surely depending on minus x2, and similarly xm will be surely depending on minus xm. I don't know whether they are dependent or not. I don't know whether x2, x1, x2, x3, x4, xm are dependent or not. But one thing I am pretty sure, these three are linearly depending on x1, x2, and xm. That means they are not independent. So maximum m independent vectors I will have. What does that mean? Here maximum m independent vectors will be present. What does that mean? That means the span could be maximum m. Now if they are saying that they are mutually orthogonal, what is the meaning of orthogonal? Orthogonal means they will be surely independent of each other. Do you remember that statement? Do you remember the statement that if orthogonal vectors are present, they will be surely independent of each other? Why is that so? Because I told you this is the meaning of orthogonal vectors. That means they are making 90-degree angle. So there is no relation between them, no relation at all. So if you are having a set of orthogonal vectors, they will be surely independent of each other. So here x1, x2, x3, xn all are independent of each other. That means what will be the rank of D? Rank of D, here I was saying that it should be less than or equals to m. But if all of them are independent of each other, that means you will have m linearly independent vectors. And if you are having m linearly independent vectors, what does that mean? If m in linearly independent vectors we are having, that means rank will be m. If rank will be m, that means span will also be m only. So second line, linearly independent, m. Third line, if they are linearly dependent, then it will be less than m. Or what is less than? The dimension of D is equal to the dimension of these dimension of the span of x1, x2, x3 and xm only. Why is that so? Because they are not giving you any different dimension. What I mean to say is that they are linearly dependent. No, they are surely linearly dependent. So if the question was that find out the span of this vector set, this is v2, what will be the span of v2 versus what will be the span of vector v, which is this? So can I say that span of, from here can I say that span of v2 will be same as the span of v? Why is that so? Because this can have maximum n linearly independent vectors, and this can also have maximum n linearly independent vectors, because minus x1, minus x2 and minus xm are depending on x1, x2 and xm. No, so they are not linearly independent, they are already dependent, right? So they will not give you any space, they can give you space. Now it depends, who knows if x2 and x1 are depending on each other, then how many linearly independent vector you will have? M minus 1. Here total vectors you are having is m, right? Total m vectors you are having. If I say that x2 is depending on x1, that means this is dependent vector. So what will be the rank? Rank will be m minus 1. If rank is m minus 1, that means you are having m minus 1 independent vectors, and with the help of m minus 1 independent vectors, you will be able to create only m minus 1 span only. Understandable? Along with that, here consider in a vector space Rm should be written. Why is that so? Because dimension is also important. No? I need to tell that these vectors are having a dimension of m. If I am not even having a dimension of m, then I will not even be able to create m independent vectors. And if I am not able to create m independent vectors, then I cannot have span m. So dimension should also be given, that the dimension is m, right? So if dimension is m, then I can say I have m linearly independent vectors. Then your rank could be m, and if your rank is m, that means your span could also be m dimensional. I hope this is clear to you. All the discussion is clear to you. In whatever the manner you want to write down, let me give you one blank space. You can write down whatever the theory you want to write down, but this is just the conclusion of everything we studied. x1, x2, x3, xm, minus x1, minus x2, and dot 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 minus xm. That means these set from minus x1 to minus xm all are depending on each other. That means maximum m linearly independent vectors I can have, maximum m linearly independent vector you can have. Now you don't even know whether they are dependent or independent. So second statement is saying that they are linearly independent. That means my rank would be m only, so my span will also be m. But if they are mutually orthogonal, that means as well they are linearly independent, then also my rank would be m only. That means my span will also be m. If they are dependent, then my rank can never be m, it would be less than m. That means my span will be also less than m. And then I am saying that whether you take this vector space or you take this vector space, both will give you the same rank. Absolutely yes. Understandable? A, B, C, D. Let's solve this question. This question is simply setting up the base of next lecture actually. Okay, in the next lecture we are going to study about null space. So I am just setting up the base of null space from here. Okay, you can answer this question. What this is saying? A be a n cross n matrix and x be a non-zero column in vector Rn. Suppose the statement Ax equals to 0. Which of the statements are true? Ax equals to 0 is given, right? Here regarding x, what you can say? Regarding x, what you can say? Ax equals to 0. So what is x? X is a solution vector, no? What is x? X is a solution vector. What is the meaning of Ax equals to 0? Last lecture, this was your x, no? x1, x2, x3. So x is a solution vector, right? So if I am saying that, how many solutions I can have? Either I can have unique solution or I can have infinite solution. If I am having unique solution, one second. If I am having unique solution, what does that mean? x1 should be equals to x2 should be equals to 0. And if I am having infinite solution, that means infinite value of x1, x2, x3 are possible. But what they are saying, x is a non-zero column vector. That means this condition is not even possible. When you get this condition, when your rank of A is equals to n, n is the number of variables. That means this condition is not even possible. Non-zero column are there, no? That means you are having infinite solutions. What does that mean? Rank of A has to be less than n. That's it. And if rank of A is less than n, what does that mean? This is 0. That means A is non-invertible. Homogeneous system has non-trivial solution. What is the meaning of infinite solution? Non-trivial solution. So yes, it will have non-trivial solutions. The nullity of A is at least 1. Why is that so? Why is that so? At least 1. Yes, nullity. What is the meaning of nullity? Nullity means number of variables, let's just say, which is 3, minus the rank. Rank has to be less than 3, no? So let's just say best case rank would be 2. So at least 1. So yes, nullity has to be at least 1. Okay. What is n? N is the number of variables. N is the number of variables. Or you can say this is your n. There are n cross 1. So this is your n, which is number of variables only. Is that clear to you? Ax equals to 0 is given. You got to know that x be a non-zero column vector. That means 0, 0, 0 is not a solution. So if this situation is true, that means you need to have some solution. So which solution would be possible? Infinite solutions would be possible. And infinite solutions are possible. What does that mean? If I say that for ax equals to 0, this is one of the possible solution. What does that mean? There will be infinite solutions for sure. If I am saying this is one of the possible solution for ax equals to 0, this is one of the possible solution, then I can surely say that yes, the system will have infinite solution. Why? Why I can say so? Can anyone tell? Because you know that ax equals to 0 will surely have 0 0 solution. No, it will surely have 0 0 0 as a solution. Because what is ax equals to 0? Ax equals to 0, let's write down this equation. Ax1 plus bx2 plus cx3 equals to 0. dx1 plus abcd e f x3 equals to 0. g h I. Right? So you know that surely this will be one of the solution. For sure. There is no doubt. But if someone comes and say that I am having this also as a solution, this is your ax equals to 0, right? If someone comes and say that I am having this also as one of the solution, so you would say two solutions are possible. This and this, two solutions are possible. Will you say it or not? Two solutions are possible, right? You will start saying something like this, that two solutions are possible. But you know that two solutions are never possible. If two solutions are possible, that means for sure infinite solutions are possible. Is that clear to you or not? Because I told you either I can have no solution, or I can have one solution, or I can have infinite solution. But for ax equals to 0, for sure there are only two conditions. Either I will have unique solution, or I will have infinite solution. For unique solution, what was the condition? That means it will be a all 0 vector. For infinite solution, there could be anything else as well, and so on. Is that clear? So if I am saying that the 0 0, it is a non-zero column vector. It is a non-zero column vector. X is a non-zero column vector. What does that mean? That simply means that x will be somewhat like this, 1 2 minus 1. It would be somewhat like this. And if it is somewhat like this, if it is somewhat like a 1 2 minus 1, what does that mean? That means this particular system will have infinite solution. If this system is having infinite solution, that means row rank of A has to be less than n. And if it is less than n, that means determinant would be 0. That means A will be not invertible. All the options would be correct, and nullity will be at least 1. Right? Understandable? So I hope this point is clear. We will pick up the next lecture from here only. Okay, so I have just set up the base of the next lecture. Understandable? So we will continue the lecture and we will pick it up from here. What we are going to study about? Null space. So what is the meaning of null space? If ax equals to 0, then x is said to be in the null space of A. Okay, so this is the meaning of null space, which we will see in the next lecture. So the last question I took to set up the base of next lecture. Understandable? So this is the part 1, then we will have part 2. Okay, yeah, thank you very much.